Well, all right. Good morning, Jen. How you doing?
Yeah, I'm pretty good. What about yourself?
Awesome, awesome. Nice being here with you today. My name is Juan. Some of you already know me from previous Hackathon regular calls, community calls. Here at Scroll doing a lot of community stuff. And happy to be here today, hosting these workshops for uh, in in uh, in preparation for the Vortex Hackathon that's happening later this week. It's our first hosted hackathon by Scroll, joined by amazing partners, which we're very grateful to. And today we're going to be having a series of workshops to get you guys up to speed on how to use these techs on Scroll. What about yourself, Jan?
Yeah, I'm also super excited to support this first Scroll Hackathon. Also looking forward to have those 8 incredible workshop partners today doing technical presentations to learn about what to build on top of Scroll. So for us, I'm part of DoraHacks. If you haven't seen that yet, we're super excited to support this hackathon. And also like tomorrow, there's the opening ceremony, so you should tune in tomorrow as well. Yeah.
Awesome, awesome. Tomorrow's ceremony, I think I'll also be there. So looking forward to that. Today, I want to share before we jump to our first workshop. I want to show a little bit of what the agenda is looking like. Let's take a look. So we're gonna kick it off with Aztec telling us about how to use Noir on Scroll. Basically, build your CK dApps using Noir. We're gonna be having Cyfrin shortly after, OpenZeppelin, Ankr, the Graph, Covalent, and Sindri. So a lot of workshops lined up for today. We're just kickstarting the first one now. We have our guest speaker waiting for us. So I think without further ado, we can invite our friend Pedro to the stage and get this thing started.
Yeah, and for the
So,
audience, in the meanwhile, if you do have any questions, just drop them in the chat. I'm happy to answer them later. So please go ahead, Pedro.
of course, Pedro, how you doing?
I'm fine. You? How's it
All great,
going?
all great. Yeah, excited, excited. It's a bunch of stuff happening today. So we have 8 different workshops. We're kickstarting it with Noir. What do you think? Is it the place to start?
Looks looks good. Let's keep some of our privacy, I guess.
I know,
Cool.
right? All right. Awesome.
So
You want to tell us
yeah,
about what you're doing at Aztec, Pedro?
yeah, I'm a DevRel engineer, so I build a lot of tooling examples, starters. So that's basically and obviously workshops and everything. So I'm gonna be the first point of contact if you ever need anything. Basically, if you have any question, that's usually the first person that you get gonna talk to is me or the rest of the DevRel team.
Awesome.
So yeah, if you have any question, just drop it. I'll try to pay attention. So yeah,
Speaking of which,
let's.
speaking of which, we do have some cool resources I'll be sharing on the chat through the day. We have a Telegram group where you can join, ask questions, find team, a whole bunch of stuff for you to get, support during Vortex. So we're ready to start it here, Jan. So I'm gonna kick us both out of the stage and leave Pedro to do his thing.
Sounds good, LFG.
All right.
Cool. So I hope you can see my screen. Yeah, apparently you do. So the idea is here to just a quick intro to Noir. So I'm gonna not have time to go a lot into it, but hopefully this will be kind of a primer, and you're gonna find your own way with the other stuff. So basically, yeah. Apparently, you would get your money back, but that's not gonna happen. So let's just go on this rundown just to explain a little bit of what ZK is, and especially how ZK in the context of Noir is a little bit different from ZK in the context of, for example, Scroll. Um, and yeah, why do they work well together, basically? And then Noir, and why is Noir? Why did we build Noir? Then we're gonna be just going on a project. We're probably not gonna have time to go over the whole project, but still gonna talk a little bit about the tools that we have. And then finally just hack something if we do have the time to do so. So basically we know that zero knowledge proofs are powerful. We know that you can both make things very succinct, so you can prove computation in a very succinct manner, and keep everything public. And that's basically what all the ZK VMs are doing. But you can also hide some information and basically allow for some inputs to be private. And that's basically where Noir excels. It's just keeping some of your inputs private, and you basically prove that you know some things about those inputs without disclosing them. But again, with great power comes univariate polynomial commitments. So that's kind of the big problem with ZK, is that you really need usually you really need to understand the math behind it, and that's why we built Noir, because we need this kind of usable universal ZK domain specific language that works everywhere. And we like Noir. We like Rust. So Rust is a nice language. There's some cool properties, the whole typing system and everything. So we just kind of copied Rust, and that's it. So if you try to find the differences between Rust and Noir, you're gonna have a bad time. Yeah, basically there's almost a drop-in replacement, especially if you write Noir and then you just put it into a Rust program. It will work almost out of the box. So if you try to spot difference between these two programs, I guess like the color give them away a little bit, but yeah, one of them is Noir and the other one is Rust. But the idea, I guess you get the idea that you find it's very, very similar, and it's often even too abstracted away, and it's interesting how these two languages achieve different goals but still have the same syntax. So the idea is that you can write code and not circuits, so you don't need to understand how the circuit works, how the math works behind it. You don't need to understand how the wall you don't need to imagine that you are building a electronic circuit or anything with the gates and anything. You just write your own code. You just write code like you would write JavaScript or C or Rust or whatever, and then out comes a proof of what you have just done, and you can verify it either off chain or you can verify it in a smart contract. And that's, I guess, the most interesting part for this hackathon, that you can basically prove something and then verify it on a smart contract. So the idea is that you don't need to understand how ZK works. Basically, you need to understand some concepts about ZK, and those are the ones that I'm going to be talking about today. And then from then on, you just go and do your own thing, and yeah, you're going to be fine. So, like our build plan, again, not sure if I'm going to have time to go over the whole thing. I initially designed this in 3 chapters. I'm going to drop the last one most likely. So I'm going to be talking about Noir, about Nargo, the syntax of Noir, how can you write tests, and basically generate your proofs. I'm going to introduce a little bit also the Solidity contract generator, because I think it's quite important for this. And then the standard library and how can you use other libraries, other dependencies. And then if we do have some time, I'm going to be talking about the browser. But don't fret if there's no time to go over the browser, because I'm going to leave a lot of resources at the end for you to basically learn by yourself. And basically, if you do have time, we're going to be talking about how to use this on your dApp. Yeah, verifying proofs on chain can be a little bit of a headache, but I really believe this is important for today, because after all, you're gonna most likely want to verify your proof in a Noir circuit, in the scroll chain. So sorry, my notes are locked. Okay. So yeah, I'm just gonna stop making memes because I like memes. Just go, and here are some resources. Yeah, just go check out. This is my profile. I guess it's the least important thing here. Then you have like the Noir docs, and you have some workshop resources that are probably outdated. But most importantly, you should get Noir docs. And this is no big deal because you can just go on noirlang.org, and that's basically what I'm gonna be doing. So let's basically, let's hack. So let me get my project. I'm gonna open a new tab. I'm gonna say noirlang.org, and these are the docs. And basically, if you read the docs, you can go straight into Solidity, like coming from Solidity and straight into how to verify that with Solidity. But let's just go and read the docs first, and just go slow with it. And so here's some quick introduction, but what we really care about is about getting started. And so the cool thing about Noir is that it's very, very easy to start as well. So you just need to install Noir app. So if you are comfortable with Foundry, you know what Foundry app is about. And if you're comfortable with Rust, you know what Rust app is about. And so we just came up with Noir app, which is basically the same thing. So I'm going to start a new terminal here. No, I'm not going to want to update this. Yeah. Okay, so you can just go and copy paste this thing, and it will install Noir. Basically, you probably want to like um, start a new terminal because it will install something on your path. So I hope you're following along. I'm gonna speak a little bit more because this can take a little bit for you. But yeah, I do recommend you to just start a new terminal. Uh, or just go and run like source just to source your path. You can do this in WSL as well if you're with Windows. Actually, we do have some core developers that are on Windows, believe it or not. So then you just go and install Noir. You just run Noir, and that will install Nargo for you. So Nargo. So again, if you know what Rust app is, you know that it will install Cargo. And so Cargo is kind of a one-stop shop for everything Rust. It will get your dependencies, it will install the packages, it will run your program. And so we did basically the same thing. We just renamed it to Nargo. Nargo, Cargo, Rust. Yeah, we go. You know how it goes. Noir. Anyway, uh, after running Noir, you should have Nargo. So you can go Nargo version, and you should get a version. I don't even know which one is. Okay, this is version 26. And so basically, you have a bunch of commands here. You can go Nargo help, and there's like all the commands you can do. Some of them are really, really cool. Some of them are, just, I guess, for example, the LSP is a cool one because you're going to be able to run tests if you're using VS Code like I'm doing here. So I'm gonna go Nargo init to start a new project, and this will basically create a new project where I am. If you want to use Nargo new, it will create a new directory with your project. And this is basically how a basic Nargo program looks like. So it has a main.nar file, and I'm gonna explain a little bit about what this is. Yeah, Docker. I don't know why Docker wants to access my. Anyway, and then you have Nargo Tamal, which is some information is about your program, like authors, like the type of program you have, because you can basically have, for example, a library that just provides functions for other programs. But in this case, I'm going to keep it simple and just use a simple binary. You also can define some dependencies, and I'm going to basically hopefully touch on this if I do have the time. Anyway, let's go on this main.noir file and try to understand what's going on here. So you have function main. This is okay. And then you have this field thing. So you can think about field a bit like a kind of a big integer, right? It fits some stuff, but it doesn't really apply any range checks. So for example, it will gladly overflow if you just if you just add a bunch of numbers to it, so you can go like 1 minus 2 and it will just overflow. And just how finite fields work. So basically this is an element of a finite field. But for basic arithmetic, you can just use this. Another thing that you don't get in Rust is this pub thing. So basically this tells you that this variable is public. And I'm going to show you an example, right? So basically everything that all the verifier knows is this y. This x is kept private. So this program then just asserts and checks that x is different from y. And yeah, that's basically it. So I'm just realizing that probably my screen is kind of small. So maybe I'm gonna share just that window. This could be helpful. Okay. I hope I didn't screw up. Okay, yeah, cool. So it's still kind of small. How can I make it bigger? Oh, cool, nice. Yeah, now it's bigger. Cool. So all this program does is just checks that the x is different from y. In other words, you're basically telling the verifier. You say, I know a number that it's not this number. So maybe another cool example would be, I know a number that it's bigger than this number. And so you can basically do it with, for example, an age, and you can say, yeah, I know my age. I'm not going to reveal it, but I can prove that my age is bigger than 18 years old if you're in Europe, for example. So yeah, to answer your question, yeah, it's not for a test. It basically says that you're proving that x is bigger than y. So it will fail if your x is different from, if it's not bigger from y. So I'm gonna give you an example. Oh, sorry. To compare, you need to cast them. So I'm gonna cast them as integers. And so I'm gonna give you an example of a test that. So I'm gonna say that I am 33 years old, and so I can prove that I'm older than 18. And so my quick test will basically prove that. So I'm just gonna run it. It'll say, okay, cool, it's run correctly. So if you want to do that on the terminal, just go nargo test, and it'll say, yeah, it passed. So basically, if you, yeah, I'm gonna make a test that it's supposed to fail. So I can go say test and then should fail, and like a test should fail if I am 17 years old and I want to prove I'm test main fail, and I want to prove that I want to prove that I'm older than 18. This test will pass because it's supposed to fail, right? So it's yeah, it's supposed to not go through. So tests are really cool, and that's something that you get in RAR that you don't get in a lot of other ZK languages. It basically allows you to make sure your program compiles and runs perfectly before you want to actually prove something. If you want to actually prove something, you can go and run nargo proof. Just going to run nargo check before, because I need to build these two files. So these two files are basically the verifier and the prover. And so these are the inputs to your program if you are proving something, and these are the inputs if you are verifying something. So if you look at this, it's going to be clear that since X is my private input and Y is my public input, then the verifier only has access to this one. And yeah, if when we generate our Solidity verifier, you're going to see that quite well, basically. That the verifier doesn't know anything besides Y. And so I'm going to put here two values. I'm going to put my age, 33. Am I 33? Yeah, I'm going to be 34 in August. So I'm going to put my values here. And I'm going to know and nargo proof. And this will make an actual zero knowledge proof to say the proof, like, it doesn't say much. I guess that's a wall point, right? And basically this proof it's basically an attestation that says I know a number x which is bigger than y, and I'm not going to tell what x is. But the verifier only has this number. So verifier only has this 12, which in hexadecimal is 18. So yeah, just to make it clear, I can just make 16 just to make sure, or 15 just to make sure it matches up. So yeah, so this okay, sorry, not 15, 14, because it starts with. Okay, cool. Oh shit, yeah, sorry, I'm yeah, my brain is melting. This is hexadecimal, so obviously it's not gonna match unless it's less than 10. Anyway, I think you get the message here. Cool. So you wanna run a Solidity verifier. So if you go nargo help, just one thing, you can obviously go nargo verify, and it will verify your proof. So yeah, basically you could send this proof to someone else, and they would be able to compile and run it right out of the gate. So you can now go nargo codegen verifier, and this will generate what you care about, which is the verifier contract. So this doesn't do much. I mean, it's a library. It has a huge bunch of assembly code, right? You don't need to understand it, obviously. You just need to care about the interface, which is the things that you're gonna actually call, and this is the verify function. So the verify function. So this is the one that you will care about. So basically, you need to pass the proof as a call data. It's just a bunch of bytes, and then your public inputs. And so yeah, this is a contract. You can deploy it. And just to give you an example, I'm gonna open Remix and do that basically. So I'm gonna share my other screen. Cool. So Remix. Yeah, I'm gonna start on the side. I'm gonna start an Anvil node so I can connect to it. And here I'm gonna start a new project, just a blank one. Just gonna create a new file, say plonk so I'm just gonna literally copy paste it. It will complain and say, "You don't copy paste it." I say, "Yeah, no problem. I'm gonna do that anyway. I don't care." Oh, sorry, it's not sharing the screen, is it? Okay, yeah, it is. Oh, kind of small, right? Much better. Anyway, you don't need to understand this. But basically, I'm going to compile this. If you compile, it will say, "Oh, the stack is too deep," and that's just because we make a bunch of nested calls. So you can just enable some optimization. I'm going to put 500 rounds of it, and it will say, "Okay, cool, I'm good to go." It will complain about some unused function, and that's okay because we're making most of the function calls are done using assembly, so it doesn't know we are calling them. So I'm going to connect to my Foundry network, which is hopefully running on this port. Okay, it is. So I have a bunch of money here. So I'm going to deploy this thing. So if you recall, my program was just basic x is different from y, where you don't know what x is, but I prove I know what x is. So I'm going to deploy this ultra verifier contract, and I do have the contract here. So I can get the verification key. This is a pretty big deal and a pretty important one, because you want to check that you are actually using the contract you want, right? And not just not just any contract. You need to check that verification key matches with the one that you are using, the program you're using. And so you should for example, like compile your contract, sorry, your circuit, and know what the verification key is. So this will be important later on. So I'm gonna just pick that proof. I know you're not seeing that, but I'm just, yeah, trust me, bro. I'm gonna use the proof I just generated when I was sharing that screen. Sorry, I think I added some other character. V0RTEx. Cool. So I'm gonna put my public input. So if you recall, I'm saying that I know I know my age, and public input is gonna be some age. And so let's say that I'm calling this from another contract, and my public input is going to be in the contract, and it's going to say 18. So you can only interact with this contract if your number is bigger than 18, but you don't need to tell the contract which number it is. So if I call this, so yeah, public input, needs to be an hexadecimal string. So I'm going to say, yeah, this is 14, but it's okay. It said, oh, sorry, expected array value because it needs to be an array. Sorry. Yeah, here it is. Needs to be a string. Cool. And it just says true. So it's kind of anticlimactic, but I guess you get the stuff. So basically, you have a proof that you know a number that it's bigger than 14 in this case. And your public input is sent by the contract. So the contract just inputs 14 all the time. And so this is like the magic of ZK and the magic of Noir, because you can basically input whatever private value you want, not reveal it, and still be able to prove that it's bigger than a publicly known value, just such as this. So basically, the way that you would run your contract now is just to deploy this one, and then just in your next contract, you would say, yeah, this is a type like type ultra verifier, and you put it. You can make it in the constructor. So in your other contract, you would say constructor ultra verifier. So yeah, I'm assuming that you are comfortable with Solidity, but that's basically how we do. You would say you would do it verifier, etc. And then just to call it in your other contract, you say verifier, verify, and then your whatever proof you are. And then in the end, you obviously want to pass, like as a magic string or something, you want to pass your number. So no one will be able to change this public input. But still, your users can prove that your private input is bigger than um, this public input. So this is Noir in a nutshell. So I promised that I would give you some resources on how to keep learning on this. So yeah. So what can you do now? So you basically can go on the Noir starter repository, and this is basically a starter. It's basically it will give you some projects you can start with. So you have an example that starts with Foundry, so it just has a bunch of circuits, and this is an interesting one if you want to understand how contracts interact with each other. Just as I was mentioning. You also have like this fit hard hat example, which is, as the name implies, it just uses hard hat. It's a React project, and basically presents you some inputs. You also have Noir examples. So Noir examples, and these have like more advanced examples. You can draw from them as well. You should also check obviously the documentation, and all of this is here basically. You have a bunch of how-to guides on even on stuff like recursion and dev containers. Merkle tree proving, you should also check the explainers if you want to know anything, and the standard library and all the things that you can do with like big integers and all the hash functions you can prove and anything. So yeah, that's it. And yeah, I think we're about time. So if you have any question, feel free to reach out on those links or the channels that you already have to be in touch with us. And we're going to be answering as fast as we can, basically. But yeah, I'm pretty sure you're going to be fine because it's a nice and easy language to work with and quite powerful.
Awesome.
Thank you for
Well,
watching.
can you hear me there, Pedro? Yeah, right.
Yeah.
Awesome. Well, thank you, Pedro, for this amazing workshop. It was very short. I know to explain. Maybe selling Noir in just an afternoon was very ambitious. But hey, listen, we set out some resource links on the chat. We'll also be uploading this video with all these resources attached to the description. So also people can find us in the Telegram group for support to hackers. So in general, I mean, if they want to definitely if they want to hack with Noir, they'll get more than enough help. So tell me, Pedro, just before letting you go, I'm very interested. What is the most interesting hack you've seen with Noir in your experience so far?
Oh, that's a cool one. Uh, yeah, it's a difficult question because people have been building the most amazing things with it. Uh, I would say like there is probably Sarma, which is basically a project that uses proof. It uses proofs of LGML encryption to hide uh, transfers and other information, and basically make everything private on chain on an EVM chain. Uh, and that's really cool. So you should check out Sarma. That's probably one of the most interesting I've seen. In Yeah, but people verifying passports, people doing the most crazy stuff with Noir, even things
Nice.
that are difficult to wrap your head around them. It really seems like black magic. So hopefully, people from this hackathon will bump into these examples and improve on them. So yeah.
Super cool and
Awesome.
insightful presentation. What would you like to see from hackers building at this hackathon?
I I think like most of all, it's like people building new things, and we don't really care about like very complex examples. It's mostly like people to get to know Noir, and like having fresh eyes on Noir is quite important for development experience as well. And mostly like to build like games, build apps, build actual applications instead of being building like the newest cryptography or commitment scheme or anything. It just actually build applications on Noir, and that's the most amazing part of Noir. Is that you just can write a library in a day or two, or a game or something, and it's crazy that you can verify all of this in a zkVM like scroll. It's just mind-boggling. So yeah, it's not necessarily improve on Noir, mostly building stuff with Noir. That's what we want from this hackathon.
Awesome. Well, thank you, Pedro. We gotta continue today's workshop sessions, but really appreciate you being here. We'll upload the workshop later today, so I'll see you around.
See you. Cool.
Awesome, Jan. So we take a quick 2 minute break before we go on to our next invited guest. We have Alex from Cyfrin to talk to us about what people can do with Cyfrin.
Yeah, sounds good. See you soon.
Awesome. Alrighty, we're back.
Yeah, sounds good. I'm super excited for the
I
next
can't.
workshop.
I'm
Go
not
ahead,
getting
please.
audio.
You can't hear us?
We can hear you.
We can hear you. Let's give Alex a second here. That's totally fine. Cool. So we have Cyfrin up next. We have Alex Rohn, CTO and co-founder of Cyfrin. I'm especially excited to see what's up with Cyfrin and what people can hack with Cyfrin.
Hey guys, can you hear me?
Yes,
I can
yes,
hear you
fine.
guys. Can you hear me? Okay, great.
Yes. Yep. Cool. Awesome. Jan, so I think we keep it short intro. We give the stage to Alex.
Yeah, let's hand it over to Alex. He will do a presentation about the future of Solidity static analyzer. So I'm very curious about it. So go ahead once you're ready.
Awesome. Thanks,
Alex,
guys.
Ready?
I'm ready. All right, let's do it. GM, everyone. I'm Alex. I'm co-founder and CTO at Cyfrin and co-maintainer of the Adderin code base. Now, Adderin is our newest tool that we've released. And I'm going to walk you guys through some slides about how it works and a bunch of information, and then we can walk through some code to intro everyone to how to contribute to the tool. Okay, so a couple of things I'm going to go over. What is Adderin? How does it work? What is an AST, which is a term you'll be hearing quite a lot during this talk. What makes a good detector? Again, another term that we'll go into a little bit more, and then we can jump into some code. So first up, what is Adderin? So first and foremost, Adderin is a static analyzer. Now, for the uninitiated out there, static analyzers search through source code to try to identify security issues in the code. Now, this is important for a number of reasons, but especially important for Solidity engineers because there are just so many ways to write bugs and introduce vulnerabilities. There are so many foot guns and easy ways to do it. And plainly, there are just not that many tools that exist to help devs or prevent bugs from being written right now. So the way Adderin describes these issues to devs right now is that it prints out a markdown report with the issues in the dev's code, and an example of one of those issues in a markdown report you can see on the right there. And second of all, it is a framework for creating detectors. So what is a detector? We'll go into a bit later, but briefly, a detector is something that searches for and finds a particular issue within a set of smart contracts. So for example, if I created a reentrancy detector, I would specifically write that to find examples of reentrancy in a bunch of smart contracts. Okay, how does it work? So zooming out at a super high level, this is what happens when you run Adderin. So firstly, Adderin compiles the smart contracts. So we lean on Foundry to do this. This input files that contain ASTs, also known as abstract syntax trees, that describe the Solidity code. Now we'll go into ASTs a little bit more later, but for now, we'll just go there. Secondly, once these ASTs are produced, they are, along with the source code, loaded into Adderin into something called the workspace context. Now, this is a huge structure, huge data structure with all the information about the smart contracts that were loaded into Adderin, their code, and most importantly, the AST. Once that's loaded in, Adderin calls out to each detector, specifically the detect function, and injects this workspace context. So every detector will have the entire context when detect is called. That detector then searches through the workspace context to find the specific issue it's looking for. And if it finds an instance, saves it. Saves the exact location in the code base, everything it needs to about that particular issue and where it is. And finally, once all of the detectors have finished running, Adderin goes back out to the detectors and say, hey, What issue did you find? Give me all the information. I'm going to print a report. So that's a super high level, and we'll go a little bit deeper into the code a little bit later. So we've done what is a Derin, how does it work? Next up, what is an AST? Now, AST is a data representation of any piece of code that can be written in any language. Every single programming language has an AST structure. And an analogy from the web scraping world is if you've ever scraped data from a website, or if you've ever built a web scraper, the page that you open in the browser is what you see, but the HTML behind it, that's what has all the data in it. That's what you actually scrape. Now, similarly, the Solidity smart contract code is what you see, like what you see in the browser, but the AST behind it has all that data that you need, and that is what we scrape in a Derin. Now, the example that you can see up here shows an example from a website called astexplorer.net. And what you can do here on the left panel is write a smart contract or paste some code. And on the right panel, it will show you the AST that is generated from that code. Now, as we can see in this contract, it's just a simple counter contract. You've got the pragma, you've got the contract definition and counter. There's a state variable, there's 2 functions in there, and a bunch of other stuff, right? Now, if we look to the right, the base AST node is a source unit right at the top of that panel there. And that source unit has a bunch of children. It actually has 2 children. So the first is the pragma directive, and the second is the contract definition. Now, the pragma directive isn't expanded here. If you go to the AST Explorer website, you can actually expand and find out more information. But if we expanded that pragma directive on the right, we would see the information about it being 0.8.13 and some other information about it, like the caret at the beginning. The contract definition just below it is expanded, and we can see some information about it. So the name is counter. Yeah, that makes sense. It doesn't have any base contracts because it doesn't extend from anything. And it has a bunch of subnodes, right? We've got a state variable declaration. So that will be for our uint256 public number. We've got a function definition. That's going to be for set number. And we've got another function definition called increment. And if we expanded those, every time we expanded and go deeper into the tree, we get more and more granular information about those specific pieces of code. And this AST, this structure, is what each detector that we write in a Derin looks into and tries to find patterns that demonstrate that there are issues there, known issues there. Okay, so what makes a good detector? So first of all, it finds a valid security issue. It's a no-brainer. So there are a bunch of places that we can find valid security issues. Previous audit reports. There are many audit companies that publicize these. There's competitive audit platforms that publish the results of competitive audits. What you will find is many issues that are found by researchers could be written into detectors. There are many common issues that are seen in many reports that could easily be automated because they're just kind of like pattern matching. But the best place to find them all is Solidity, which collates issues from many reports across many platforms all in one place, links them together. It's a really easy place that you can learn about issues, security issues, and find the common ones. Secondly, it should be accurate. Okay, it should find 100% of the true positives, which it finds every single instance of the issue that it claims to find, so it doesn't miss any. And it should have low to no false positives. It should not report any instances unless they do match the issue that it's described to detect. Basically, if there's a lot of noise, a lot of false positives, it drowns out the valid instances and it's not as valuable to developers. And finally, it should be efficient. Lots of complexity, like many nested loops, is bad for a Derin's performance. So we want to make these detectors as efficient as possible, and that helps a Derin be super fast. Okay, before we go into some code, I'll leave this up just for a few seconds, some links to the Adairin repo, to the docs, and some Twitter links for Cyfrin. I'm sure you guys are following Patrick already. I should have put that one up as well. But to me and Cyfrin audits, I'm going to swap my screen share just to something else so we can dive into some code. Okie dokie. Okay, so that was like a high-level overview. What I'm going to do is walk through some of the repo structure, and we'll go through a basic detector and examples of how to test it and write it. So ignore all this stuff for now. We'll just go through the folder structure. So to write a detector, the detectors live in Adairin core, source, detect. Now we have two severity classifications here just for simplicity. High issues are ones that you should definitely fix as a dev. It is a high likelihood that this thing could result in a vulnerability that could be exploited. And low, they're more like advisories. You know, if you want a really tidy code base that's readable and kind of all the bells and whistles, you should look to try and resolve these two, but they probably aren't going to completely balk your protocol. Okay, what have we got up next? So to test these, so if we write detector, and we'll go through an example of one here, within the Adairin repo, we actually have in tests contract playground a Foundry repo that we, when we're writing detectors, we write contracts for. So we can write a contract that exhibits the good and the bad of what we actually want to catch. So here's one that I've got comments, right, we want to catch this one, we want to catch this one, we want to catch this one, but we don't want to catch this one. So every example that you can think of, every derivation of the issue that you're looking for, and potentially maybe false positives, we can write a contract. And then, as I mentioned earlier, we can generate the AST that then we can feed in to the detectors. So if I've got my Foundry repo here, the way we generate the AST is, if we go into contract playground, we use forge build --AST, and nothing changes here because I changed nothing. And what that does is it prints all the AST for all of the contracts into the out folder inside our contract playground. Okay, let's walk through. We'll get back to this in a bit. We've got an example here, but I'm going to walk through the structure of a detector. So this is our detector. It's written in Rust. And to put it, long story short, this is the API that every detector implements. These are the functions that every detector should implement if it wants to be included in a report. Okay, so the first one is detect. And this is what I mentioned earlier. This is where Adairin injects the workspace context. So by this point, all the contract ASTs have been loaded in, and Adairin is saying, hey, detector, go and detect stuff. So I'll expand and go into that later. Next up is title. So this is the title that will be printed for this issue in the report. Next up, we have a description. So, hey, non-reentrant modifier should occur before all other modifiers. Okay, so this particular detector is finding instances where the non-reentrant modifier is used, but it is not defined as the first modifier. So Solidity, the modifiers are executed sequentially. So they will be executed the first one, the second one, third one, and so on. So this particular detector finds instances where the non-reentrant, like in this one, is not the first modifier that we use. And the reason is because it protects against reentrancy in other modifiers. So essentially, if only owner had a reentrancy issue, it would not be caught by this modifier. So there we go. That's the title and the description of the detector itself. Next up, we have severity. So this one is low, out of low and high. These two functions are more like system functions, so these won't ever really change. This just returns the instances so that Adairin can say, hey, give me the instances that you found. And this is a, I believe, camel case version of the name, but we don't need to worry about that for now. Okay, let's go back to the contract side of things and look into some AST. So we have, in fact, maybe I'll move this over here. Now that looks a bit scary for now, but don't worry, we'll go through that. Okay, as I said, we have two examples of functions here, and our detector should, we know, we've written this one to be the one that we are looking to detect. It should find this as an issue because non-reentrant is used, but it's not the first one, and it shouldn't find this. So when we ran forge build AST, and let me just go out there, it will have generated this file. Now, I highly recommend an extension called prettified JSON. So when we run that, there we go. That looks much nicer. So as part of this out file, there are a bunch of things that we don't specifically need. So if one's the ABI, we can minimize that. Bytecode, we don't need. Bytecode, no, we don't need any of this. What we're looking for is the AST. Metadata, oh, there we go. Okay, now we can start to dig in to the meat of the AST behind this admin contract. So let me minimize some things. Okay, this is the base node of the AST. And much like we saw in the example in the slide, the base unit is the source unit. It's just the file, okay? It's got some information about the file, where it is, the license that we use. You can see MIT at the top. The source, so that's the scope, where it starts to where it finishes, et cetera, et cetera. And it's got a bunch of nodes. Now, these are its children. So I'm willing to bet that the number of nodes and this on the source unit level, 1, 2, 3, 4. It should have a pragma, 2 import directives, and a contract definition. And then within the contract definition, like before, that will have children, and in the function will have children itself, et cetera, et cetera, et cetera. So let's open up the nodes, and we can do some minimization just to make it easier. So by the way, this is the process that I would go through when I'm writing a detector to figure out the patterns that I want to write an algorithm in the detector to find. So the first one, here we go, pragma directive. So that's this line here. And it's got all the information in there, right? Where it starts, where it finishes, and the exact literals that it uses. Okay, we can close that because we're not bothered by that. The next one will be the ownable import directive. Now you can see just how data rich this AST is. This is just for this line. So we close that. And we go to the next one. It'll be another import for reentrancy guard. It is. Okay, close that. Now, this is what we are looking for. This is the contract definition. So again, we'll close some of these just to make it more easy to reason about. The canonical name, admin contract. Yep, it's a contract. It is not abstract. A bunch of other stuff. And again, now it has some base contracts. So we expect that to be ownable and reentry guard. So we open those. And as expected, we've got one called ownable. Close that one. And we've got one called reentry guard. Great. We're not too concerned about that still. What we're concerned about is the function. So we go a little deeper. And we have 1, 2, 3. So the first one will be the constructor. And it is. Okay, we don't need to worry about that. Now the second one, this holds the problem. And we know that because we wrote this. So let's take a look at the AST. Now, we're not worried about the body. So nothing inside the body is what we're actually looking for. So I'm going to close that one. Aha, it's got an attribute called modifiers. So this seems promising. And if we look through, we've got a modifier invocation called only owner. And then we have another modifier invocation called non-reentrant. So let's think about how I can write a detector to detect this as an issue. So maybe I can get, for every function definition, look through the modifiers array. If the array is greater than 1 in length, loop through, and if I find one with a name that contains non-reentrant and the index isn't 0, then capture that modifier. That is an issue. So if we go back to, let me drag this back over here. If we go back to our detector and we open detect, So this is quite a small one. Let's have a look what we're doing. First of all, the context is injected, and we say, hey, context, give me all of your function definitions. I'll go into the function definitions a little bit more in a bit. But this gets all of the function definitions for the entire workspace that we loaded in. So it will be getting every single function definition from every single contract that Darren fed in. And this loop says, right, for every function definition, if this function definition has more than one modifier, loop through the modifiers. If the modifier name contains non-reentrant and the modifier index is not 0, capture that modifier because this is a problem. So in this case, it would capture this non-reentrant modifier. And what capture does, it is a Darren macro. So it's a macro, which is a Rust term for like a reusable function where types don't need to be known. And that simply adds it to our found instances. Now, this is a lot of information at once. I realize that. So please feel free to click around. There's a lot more context in the docs as well. So that is essentially just our detect function. And the last thing we do is we print true or false with an OK signal, depending on if we found something. OK, what's next on my list? Testing. Testing. OK, so let me undo that. So we're able to test our detectors. And every detector, if we scroll down to the bottom, has this test module down here. Now, in our tests, we have some helpers that help us test specific contracts to detectors. So here you can see we're using a test helper called load contract. And what we're feeding in is just the path to this admin contract.json. So you go in test, contract playground, out, admin contract.json. And that creates a new workspace context for us just with this contract in it. We then set up the detectors, and then we start to make some assertions after we run detect. So we know there should be an issue in this contract. So we assert that something was found. We assert that one was found because, well, we've only written one here. It shouldn't find any more because then it would be false positives. We can even assert the line number that it should be on. So line 10 here. And we could go up more granular into what should be in that particular node, etc. But for simplicity, we make some other assertions like the severity, the title, the description. And thanks to some nice Rust extensions, we can actually run this test from here. And would you look at that? Super quick. 1 passed, 0 failed. So that's a very quick run through of how you can test stuff. Again, have a click around, look into the docs of the docs pages that we have on the Cyfrin docs site. They will have a lot more information. Now, if you wanted to run this detector as part of an Darren run, as part of this, specifically this local version of Darren, you would use it as part of the cargo run. But first, we need to register it. So again, there's a little bit more context because this is coming at you a bit quick. Essentially, if you're new to Rust, what you need to do is make the detector that you just wrote available to the rest of the application code. So what we do is we add it to the mod.rs in this folder. I believe that's it there. And this just makes it available to Darren so that it knows to call out to it once we've added it to detector.rs. So there are a bunch of places that you need to add it here as well once you've exported it. So we import it in here somewhere, add it to this list. There's a couple of places that we add it. But once you've done that, you are good to go. And the way you run your local Darren instance on the Foundry Playground is you run cargo run -- tests contract playground. Let's see that go. And bam, the report has been created. So if we open, the default is report.md. You can change that with extra flags, output flags, whatnot. But let's open report.md. We'll scroll to the top. So this is the report that it produced. And here you can see all the issues that it found. It starts off with a summary of the files, the file space, the number of lines of code, what issues it found. But let's look specifically for the one that we were talking about. So this one here, L12, non-reentrant modifier should occur before all other modifiers. Now what we should see is this line. So if we click down, it should scroll for us. Okay, so the title that we set in our detector over here, non-reentrant modifier, the description appears. And would you look at that? It found the instance we expected it to on line 10. You can even click to it if you wanted to with a nice code snippet. It even found another one in a separate contract that looks the same. So if we click there just to check that it was correct, there you go, parent chain contract, got the right line, cool. So that is it. That is that tiny piece of, well, relatively small piece of detector code here produces a lovely report that developers can consume, and as they resolve these issues, they should disappear. I think that is about all I've got for you guys. I'm not sure if I'm bumping up against time here. Maybe I'll put the links back up on screen for you guys.
Thank you, Alex. That was great. I actually didn't know this existed previous to this, so this is very good to know that we're getting to know these different tools through Vortex. And of course, excited to have you guys participating. Something really cool about Vortex, I think I didn't mention before, but this being an online hackathon opened the opportunity for us to plug into our global network communities all over the world. We're actually hosting meetups all over the world during Vortex. So it's exciting to see or to know that people from all parts of the world are going to be in touch with this technology and playing around with it. So that's something especially motivating about this hackathon, in my opinion.
Yeah, it sounds great. I mean, that's the main thing that we want to get after announcing this just a few days ago is as many eyes as possible, as many people interested in Rust and Solidity and security. Yeah, please come and DM me on Twitter, reach out to me, or just open some PRs and issues. That'd be very cool.
Awesome. Well, I don't think we have any questions right now, but we surely will be chatting further through the Telegram group to give support to these hackers. And I'll be uploading this bit later today with additional resources. So, yeah. Great having you here, Alex.
Sounds great.
Anything to add, Jan?
Yeah, like super incredible workshop. So thanks a lot, Alex. What excites you most about this hackathon?
I think I said it already, just getting eyes and new developers, especially that is one thing that our space really needs right now, is to introduce new developers into Web3, right? And for us, doing that with the backbone of security in mind is important. I think that's how we level up the industry, and that's what I'm looking forward to in this hackathon as well.
Yeah, that sounds pretty good. I'm also very excited. So let's take a quick 2-minute break, and then we're back with the next workshop from OpenZeppelin.
Awesome. Well, thank you, Alex. Appreciate it tons. Alrighty, and we're back. Awesome. Nice having you here. Cairo, how you doing?
Pretty good, pretty good. Thanks, guys, for having us here.
Great. So now we have OpenZeppelin up next. I met really cool people at OpenZeppelin. Haven't had the chance to meet you, but nice having you here today, sharing with our community. Vortex, spreading love with the Scroll ecosystem. So tell us what are you going to share with us today?
Yeah, so today I'm going to go over Defender, which is our security platform for developers. I'm just going to go over the new version of Defender, features, do a quick overview of Defender, how we want developers to use it, and also I have some time for bounties, so I'm just going to go over our bounties, what we're looking for, judging criteria, and yeah, mostly that.
Awesome. Yeah. $85,000 in prize pool. That's very, very nice. Speaking of which, there's also a Chainlink hackathon coming up, which we're also going to be part of, supporting a lot of good stuff happening this next couple of weeks. So cool. Kaido, you want to take us into what's the magic behind OpenZeppelin?
Yeah, sounds good.
Yeah, also
Awesome.
feel free to share a bit of your background.
Yep. All right, do you guys see the slides?
Oh, okay. I think John was asking. He wanted to know a little bit more about you.
Oh, okay, yeah. Right. Perfect. Yeah. I was just, I was going to go over, Defenders on the slides quite quickly. So yeah, Defender is our security platform, as I said. Basically, we are trying to provide tools for developers across all of the steps of development. So from coding, deploying, and also auditing, and everything else after deploying. So that is operations, how to update the parameters of a protocol correctly and safely, how to interact with governance in a better way. So we are providing modules and features on Defender, which is a platform that provides an easy UI for developers to, for example, deploy across chains deterministically, use security layers to fund wallets across different chains, so that you don't have to move tokens or gas and to like more than 10 chains. So we're providing these tools for as many developer frameworks as possible. So for Hardhat and Foundry mainly. And so yeah, we have kind of this suite of tools that we're working on.
Yeah, that sounds exciting. So if you would want to share your screen, you could just get started and start with your workshop.
All right, sounds
Awesome.
good.
I'll take us both out of the stage, and yeah, awesome.
All right, perfect. So yeah, as I was saying, OpenZeppelin Defender is our security platform. A quick background of myself. I'm Cairo. I'm a PM at OpenZeppelin. I focus on Defender and the contracts library. And so the idea with Defender is basically to provide 0 to 1 tools for developers. And the idea is to support users and developers from coding, auditing, deploying, monitor, and operations, and be able to launch blockchain applications with confidence. Compared to Defender 1.0, which we launched in 2020, almost 4 years ago, Defender 2.0 launched a couple of months ago, and the idea is basically that one, to basically build on top of Defender 1.0, but support the remaining use cases that we didn't have on the previous version. We were especially around coding and deploying. So the first one, we have secure code. So the idea with secure code is to provide basically a GitHub app that can be installed on different repos, and this app basically every time that you push a change to your code or open an API, is going to run our static analysis based on rules and our AI models. And so we have 4 models now. We have one for reentrancy across functions, one for reentrancy across the contract. We also have one for access control, which is an example is that you have certain functions that should only be callable by admins, but can be called by anyone. So the models are going to be able to flag that and show you that there's a possible vulnerability in your contract. The last model that we have for coding is one that checks that the comments and documentation of your contracts match the logic, so that the NAT spec and everything is up to date with your contract code. And the idea was also to tie closer to the contracts library. So we have a ton of rules that are specific to the contracts library, to make sure that if you're using, let's say, ERC20, 721, 1155, or any specific standard, everything, it fits according to the standard itself, that the ABI matches, that a certain logic also matches to the standard, and it also checks if there's flaws in that logic, if you are doing any wrong calculation of the balances, or if you're subtracting balances before or after transferring the tokens and stuff like that. So we have the next module, secure audit. So the idea here is to basically provide one interface for our audit clients. So instead of having, let's say, like 4 or 5 platforms where you communicate with the auditors and the clients, it's much easier to have one single platform that aggregates all of the information and conversations that you can have between your clients and the auditors. And so basically the idea is that it basically adds speed to the process, and it also minimizes confusion on the different time that you can waste managing different channels. Then we have secure deploy. So with secure deploy, the idea is to avoid unnecessary delays and post-deployment surprises, and just to minimize risk across deployments in general, which is honestly one of the most, nerve-wracking stages of a protocol or a project, is actually deploying to production. So for this, we provide plugins for developer frameworks. To be specific, Hardhat and Foundry. The Foundry plugin, we launched it last week actually, so it's brand new. But the idea is that you can deploy contracts across 4 or 5 chains at the same time, and you can have features such as deterministic addresses. So if you deploy, on multiple chains, you are going to have the same address on the contract. So it's less addresses that you have to manage, as long as the contract is the same. We also provide automatic checks on your upgradable contracts to prevent the storage collisions. So if you are working on deploying proxies and upgrading them, both on Hardhat and Foundry, the plugins are going to check that the new implementations are safe and that they're not going to provide any collisions with the current storage of the proxy. We also have automatic bytecode verification on the explorers. So if you're deploying on mainnet or scroll mainnet or testnet, as long as there's an explorer that we support, we're going to verify the contract deployment for you automatically. So this is one less thing that developers have to do, which is sometimes a bit annoying, is that you need to have an Etherscan key, for example, and you have to verify the contracts manually, and sometimes you don't really know why the contracts are not matching. So all of that is abstracted on Defender, and it's done automatically by the deploy module. All right, and then last but not least, we have monitor and operate. So the idea here is to support everything after deployments, and that is having monitors for on-chain activity. So if you have, for example, a DeFi protocol, you can use the modules to check for transactions that can revert, or if there's any suspicious activity on the protocol, you can also monitor that and connect actions, which are automatic transactions. So let's say that you detect there's a lot of outflows of tokens in your protocol. You can then trigger an automatic pause on the contract. So you can prevent any extra losses from the protocol. We also integrate with Forta, so you can use our Forta bots that run on AI models for on-chain data as well. We also have attack simulations and real-world scenarios. So if you are already in production or even on testnet, you can check for different scenarios. You can simulate what happens if, let's say, 80% of the TVL of a protocol is drained, how you're responding to that scenario. And you can build some pretty interesting stuff with governance on top of that. You can have automatic proposals for the governance, and all of these can be basically combined with each other so that you have a fully secure suite of incident response. So that's kind of a high-level overview of Defender 2.0. So the main idea is to have basically a deeply integrated user experience with also much more powerful features and an expanded scope that we took from Defender 1.0. Right, so now moving on to the Hackathon bounties. You're interested in 2 main tracks. So first, Defender tooling. So this is everything related to improving the user experience and the developer experience on Defender. We have 2 prizes for this track. So a couple of things that we're interested in is the first one, Remix plugin that allows developers to deploy on Remix through Defender using the API. And the second idea is how to, any tooling that is related to improving the multi-chain deployment experience, as I mentioned earlier. One example is that if you have multiple relayers on, let's say, like 4 or 5 chains, we're interested in a tool that basically funds the relayers. If you do one deployment across the chain, so you don't have to do it manually before and distribute the gas. So a tool that makes that easier. And then anything that is tooling related and that uses Defender is also part of this track. And then we have the second track, which is DeFi with Defender. We have the same 2 prices for this one. This is a bit of more of a general track, but focus on DeFi. So anything that is DeFi related and uses Defender applies for this track. A couple of examples that we came up with are, for example, monitoring oracles like Uniswap TWAPs on Defender, having actions that automate protocol operations every n blocks. Another idea is to rebalance Uniswap positions automatically with monitors and actions. So you can monitor for swaps on chain, and then if there's, if the position can be improved and rebalanced, then you can automate that with actions. Another idea is to basically have a workflow that pauses a protocol if there's a lot of token outflows, which is an example that I mentioned earlier for the monitor and operate modules. And then anything else that you think could be interesting related to DeFi. So you can reach out to us on the Telegram group chat for the hackathon, or you can DM me on Telegram, which is CairoETH. So now I wanted to go over quickly, actually, Defender. Let me just share this here. Okay. Cool. So here's basically the overview page for, I don't know, Juan, if you can, my screen showing up on the, here on the, there we go, thanks. All right, so yeah, this is the overview page for OpenZeppelin Defender. We have the code inspector tab, we have the audit tab, we have the deploy, monitor, actions, and access control tab. And so this basically ties back to the idea of having one main module for each of the developer development phases. So first, going to Code Inspector, this is our static analyzer for contracts written in Solidity. So this runs on our AI models, the 4 that I mentioned earlier, and also our rules that are based on OpenZeppelin contracts library. And so this is basically a GitHub app that you install on your repos, and it's going to generate a report on your code. So the report usually contains not only vulnerability information, but also information about gas consumption, how you can improve certain functions if they're highly inefficient, and also testing. So if you have certain activity that we recognize that can be improved on testing, we're going to recommend that. So we're going to recommend some fuzzing ideas, some invariants that can easily be implemented with Foundry, for example. So here is a report that basically checks for all of these different rules and provides you the specific contract name or the lines that are related to the different vulnerabilities. Here you also have the information about the GitHub repo, the branch, the timestamp. And we're also working on running reports on deployed contracts that are verified. So if you have a contract that is deployed on, let's say, Ethereum mainnet and it's verified on Etherscan, you will be able to use Code Inspector to get the code of that contract and run a report to basically get information. Then moving on to deploy, here basically users set up 2 environments, the production and the test environment. So on test, it's for testnets, and production for mainnets. And so this basically provides a UI of your deployments. We support more than 35 networks, including testnets and mainnets. So there's a lot of different opportunities of deployments in general. The idea is that you set up an approval process for deployments and an approval process for upgrades. And that means basically how Defender is going to automate the deployment for you. If you have, for example, a wallet that you want to use for the deployments, then Defender is going to request you to go to Defender and use MetaMask. You can also have multi-sigs. So if you're, for example, upgrading with a multi-sig, Defender is going to propose the upgrade automatically for you to save. So you just can go to save and confirm that upgrade. Here are a few deployment examples. So we have box, which is an implementation contract, and then we have the proxy. So you can basically check the state, the API, and everything on Defender. And here's basically that information, how it was deployed, if it's verified or not, the state, and also the API of the proxy. Here is basically, so here's just quickly going back over Code Inspector. This is how it looks on GitHub. Every time that, Code Inspector runs and detects vulnerabilities, it's going to publish a report on GitHub so that it's accessible on GitHub, but the full version, it's available on Defender. And so we deploy, here is an example of Foundry, so using the OpenZeppelin Foundry upgrades plugin. So it's really easy. It's going to deploy here the proxy for you, and it's going to implement it's going to use the box implementation, and it's also going to initialize the contract here. And then we have the equivalent, but in Hard Hat. And so this is essentially the same thing. It deploys the proxy for you and the implementation, and it also initializes the contract in that transaction. Okay, and then we have monitors. So with monitors, you can basically create, let's say, like watchers of on-chain activity. So you can track, let's say, Uniswap activity, and then you can select the contract. So you can select the Uniswap wallet. You can select, any contract or any EOA that you want to track. And so once you select it, then you can enable different transaction filters. You can make sure that it only picks up transactions that are executed correctly, or even the ones that revert, or if you only want to look for transactions that have certain amount of gas. And then you can also use just JavaScript code to filter this. So if you have any custom checks that you want to do, you can use this section here. And then you can filter by events and functions. So this is basically using the API of the contract. And let's say you want to monitor this remove object function. You select it, and if it has properties, it's going to allow you to select by the input parameters. So if it's taking, for example, a number, you can choose to only monitor the transactions that use a number that is higher than 5, for example. And then we have the alerts tab, and here you can connect with the notification channels to get alerts. We support Telegram, Slack, email, any platform that uses webhooks can be used on Defender. And then what I think is super powerful is that you can connect monitors with actions. So every time that, for example, this monitor picks up transaction, it's going to be sent to an action. And then on the action, you can do any logic. So you can respond with a transaction. You can, for example, do anything off-chain or on-chain, as long as it's written in JavaScript, basically. And then you have a few other settings like the alert threshold and the severity label for notifications. And then going over to actions, which can be connected to monitors. You have normal actions, which are actions that run every minute or are triggered with a webhook. You can also, for example, use a workflow or run every 60 minutes or every couple of hours. And so then here is the logic that you can have on your contract. So you can do anything on JavaScript. Most use cases are for sending transactions on chain. So imagine if you have an Oracle, you can detect if there's any Oracle deviation on chain, and you can respond with a transaction that updates the Oracle on chain. And then we have transaction proposals. So this is basically one-time transactions or transactions that you want to do manually. In this case, it's pretty similar to actions, but they are not automatic transactions or triggered by anything. You have to trigger them manually. So in this case, you can do swap tokens, and then you can select the contract like this one, and basically you just choose different functions. And this is a way of executing transactions, normal transactions on Defender using the different approval processes. So you can use like a relayer, you can use a multisig, a Fireblocks, or any other approval process that we support. And then we have workflows. So workflows is a combination of different actions. So if you have, let's say, 4 or 5 actions that are to do different things on your protocol, like updating the oracle, passing the contracts, swapping tokens, all of those different actions can be combined together with workflows. So you can create parallel transactions. That means that if one of these transactions fail, the workflow is going to continue. But if you have this normal action, it means that if this third or fourth transaction fails, the workflow is going to throw an error, basically error, and you know have to run it again or trigger it again. And then last but not least, we have access control. So this is more of a simple interface for your contracts that are inheriting the access control library from OpenZeppelin contracts. So, you know, usually if you go on Etherscan and the contract has different roles, it's really hard to know what users have certain roles. So with this, you can easily see, for example, what address is the owner, or if you have different roles, you can see what is the address that holds, you know, the role, or, you know, if you are the owner or, you know, you are the admin, you can also update the different roles here. You can deselect addresses and you can add new ones, and then you can save the changes and send them on chain with an approval process that is, you know, that holds enough permissions. And then we have manage. So here is basically, you know, everything that is used across Defender, more of a universal, basically, you know, features. You have relayers, the approval processes that are used across Defender, integrations with Fireblocks. Also, we have the notifications channels. So this is just tying back to what I was saying earlier about monitors. We have a ton of different platforms that you can integrate with. The address book. So here you have all of your contracts that you either deployed through Defender or that you added manually that you want to use on Defender. You have keys, secrets, and then we recently released fork networks. So if you want to do debugging or you want to test, you know, certain operations, like you don't want to send them on chain, you can fork a network, and you can do all of the you can use all of the modules on this fork network. And the same for private networks. So if you, for example, have a rollup, or, you know, you are using a certain RAS, you can basically use private networks to add the network to Defender and basically use all of the features. If, for example, the network is gated by a key, you can add the key to Defender, and then you can use it across the platform. We also have Defender as code, so you can use all of the previous mentioned features using a serverless framework. So this means that you don't have to access the UI and basically, you know, do everything in the UI. You can do it on you know, outside the UI using the serverless framework. You know, in case the team is you know, large and, you know, you don't want to have everyone accessing Defender, you can just, you know, have it outside the UI and use this plugin for that. So that's basically it. Quickly again, here are the bounties that we're looking for. Student tracks, a couple of ideas here. And you also have resources here. So we have the docs for Defender. We have the GitHub repos for the Hackathon and Foundry plugins. Everything's open source. And you also have the SDK and API documentation. And here is also one example of a Remix plugin, which is something that we are really excited about. And yeah, hoping that someone is interested in building that out.
Awesome, Kaido. That's you wrapped up?
Yep.
Cool. I think my camera's off. I'll be back here.
Yeah, incredible workshop. So thanks a lot for all the information. I think it was super insightful for our audience.
Yeah.
Awesome.
Perfect.
Cool. Do you want to? I'm going to be sharing these resources later on the bit upload to YouTube. Also, as I mentioned previously in one of the other workshops, we are hosting local meetups around the world. I think in about 15 countries. So we have a good amount of like local community, you know, supporting hackers. So I'll be sharing these resources with those communities as well for them to be able to provide to their hackers on site. So exciting to have you guys on board in Vortex. This is the very first one. We have more plans through the year, but yeah, I think Jan, do you want to add anything here?
No, I think it's good. So maybe we should also share the Telegram group link into the chat so developers can join even after the session and ask some questions to Cairo and the other presenters.
Absolutely. Let's see if I can It is. Boom. There we go. So chat posted on the YouTube chat. But anyways, for now, Cairo, we really appreciate you jumping in here, sharing more about Defender, OpenZeppelin, and what's going on, some of the bounties as well. And excited to see what comes out of this.
All right, perfect. Yeah. Well, thanks for having us. And yeah, I mean, if there's any questions about OpenZeppelin and Defender, we're going to be available on Telegram, so you can reach us there.
Awesome. Thank you,
All right.
Cairo.
Thank you. Bye-bye.
Bye-bye. Looking forward.
Awesome. Well, Jan, we did have a guest from Ankr coming up next, but they had an emergency and they won't be able to make it. So let's chat a little bit about the hackathon itself. I'm going to go ahead and share my screen here. Let's see. Boom. Here we go. Vortex 01, Dora hacks. April 24th to April 29th. All time zones are in UTC. This is a very exciting online hackathon, 85,000 USD in total prize pool. Yeah, well, what's your take on this hackathon based on your experience?
Very, very generous prize pool. So if you're a hacker, use the time and build a very cool but also impactful project. There's a lot of different prizes. And besides that, you can also get some feedback on your product itself. So it's just a very short time period. It's like 5 days, but maybe take your weekend and your nights in order to create some incredible code and a product that will impact some of users' lives.
Absolutely, absolutely. So let's take a look at some of these prize pools. So the first prize pool coming up is the scroll bounties. We have a prize pool of $11,000, which is, this is very common. We usually do this in a lot of hackathons where we want to see people deploying on Scroll, verifying their contracts, and people being able to touch the technology. We want hackers to realize how easy and convenient it is to hack on Scroll. So we usually do these prize pools for that reason, getting ourselves known out there. So the guidelines are, you just got to deploy verified. And what we're looking for is just not a simple hello world contract, but, something, some sort of product, basically. We also have 3 bounties worth $3,000 per track, 3 bounties worth $1,000 per track, and 2 runner-ups of $500 per track. Let's take a look at the tracks here. Okay, I guess there's just, 1 track.
I think we can also go to the partner bounties as well at some
Let's
point.
see where we can find it.
The different judging criteria.
Here we have the tracks. Okay, cool. So we have DeFi focused on decentralized options AMM, perp dexes with superior UX, decentralized exchanges, yield farming platforms, just something nerdy in terms of DeFi. So we're looking for, specific stuff out there that we want to see people innovate around with. We also have gaming, which is, of course, a big topic right now in terms of blockchain use cases. We also have privacy. We had a chat earlier with the Noir folks, which are the perfect partner for privacy. Cool. Let's take a look. Partner bounties. Whoops.
I think you need
partner bounties. There we go. Cool. So first up, we have Ankr. So Ankr is giving out $3,000 in Ankr credits. The description here says, we invite developers to push boundaries of blockchain. Your task is to create a project that leverages Ankr's APIs to facilitate unique, efficient, and effective blockchain interactions. Cool. We also have some resources here, which is great. Next up, we have Aztec, best gaming application incorporating ZK using Noir, best DID application using Noir, and a Noir price pool. Cool. So total value of $5,000 from the Aztec folks.
Yeah, I'm looking forward to see some cool projects that are privacy preserving. So I feel like overall we need more projects that care about privacy. On blockchains, everything is so public, and in the end, maybe there's some things we don't want to share publicly.
Absolutely, absolutely. Next up, we have Chainlink with data feeds on scroll, a total value of bounty of $10,000, where they're looking for 5 projects using Chainlink data feeds on scroll. So very, very straightforward requirements from the Chainlink team. Cool. Some additional resources here, and as I mentioned, Chainlink Hackathon is also coming up. So exciting to have hackers back-to-back entertained in the ecosystem. So we also have Covalent here with $5,000 total value. First place of 2.5K, 1.5K, and 1K. And basically, they're looking for people using their APIs, SDKs, and their GoldRush kit, which is very, very nice for hackathons, for people to get a head start with their projects. OpenZeppelin, we just heard from, total value of $5,000 for people using Defender and for people to hack around Defender tooling. So very interesting. I was at a hackathon recently where the OpenZeppelin guys had a really cool hackathon idea or track where basically you were meant to make a challenge. The hack or what they were asking for is for people to do a challenge for people to identify security issues. That was, like, in my opinion, like a really cool way to learn about security.
Yeah, and we all need more security. There's so many exploits and hacks, so I think it's very important to take a lot of care about security, build applications that solve security issues.
Absolutely. Next up, we have Sindri. Sindri has $6,000 plus Sindri credits for people using or they want to look for the most unique uses of Sindri out there. Cool. Let's take a look. Next up, we have the graph. Total bounty pool of $5,000. They're looking for subgraphs. They're looking for best use cases of existing subgraphs. So pretty straightforward. The graph, big project. Really cool seeing them here. So in general, really cool to have all these partners, chime in and support this initiative. Yeah, what do you think about it?
Yeah, I'm super excited. I think it's, as I said before, it's a really good chance to maybe grab something from the prize pool, but also if you do have any idea what you would like to build, take the next 5 days and start writing code, ship your project, and that's like how you can get started. I think it's a super good initiative in order to get started with your idea that you were thinking about last week or last month.
Absolutely. Let's see here. Register as a hacker. Cool. So you gotta log into Dora Hacks and then apply to the hackathon, correct?
Yeah, I think we're gonna go through it tomorrow on the opening ceremony.
Sounds good. Cool.
But we could go more in depth into like the details, share more about it.
Share more details. You mean the timeline?
Yes, like if you could click on the details tab, I think there's like more relevant details.
I think this is the details tab, no?
That's the partner bounties. So right next to Biddles, there's detail. And I think there's more about the submission criteria.
Well, I think my screen is stuck. That's what it is.
Yeah, it's frozen.
Give me a sec. My screen's frozen.
What are you most excited about this hackathon? What are you looking forward?
Well, I mean, as I shared, something that one of the projects I've been working on is these global meetups around the world. So getting to see people hacking from Africa, Southeast Asia, Latin America, jumping on this hackathon is especially exciting. This is something that in some places of the world, these sorts of hackathons don't have any reach. So through this community initiative, we're being able to put this technology on the hands of people who've never had the opportunity to participate in one of these things. So that's especially motivating to me.
Yeah, I think it's a great opportunity also to meet fellow hackers. If you're still looking for a teammate, go to those meetups if it's like close to you. If not, like in the Telegram group, there's also a subsection, a category where you can learn more about the team formation. So if you're looking for someone like a designer, maybe share more about your project ideas and then request that like a designer should reach out to you. But also on the Dora Hex platform, you can state that you're still looking for team members.
Cool. So yeah, we're in the detail section here on the detail tab. At the very bottom, we have a bunch of resources laid out: developer quick start on Scroll, smart contract verification guides, developer documentation, Scroll testnet portal, and Scroll architecture for whoever is like super interested in learning more about that. But in general, I think the key timelines still
Yeah,
need
there's
to
also
be
a bit
added.
about judging criteria. So like if you
Let's
scroll down a little
see.
bit, I think it's
Boom.
here exactly.
Cool. So we have originality. So just to clarify here, what is the Scroll team looking for in terms of their judging criteria? Originality, is this something that judges have never seen before? Great UI UX, is your project easy to understand and navigate? Composability, is it seamless to integrate your project? Security, did you think about security from the first line of code? Mass appeal, is this something that your non-crypto friends would want to use? And clear go-to-market strategy, have you thought about that potential market? Why is this important here? Is because I guess this hackathon's we're not necessarily looking for just hacks, but if you have like an interesting idea and you haven't been able to put it into production, I think this is a good opportunity to do so. You get eyes from different partners and projects out there with a good reputation in the ecosystem to take a look at what you're building, what you're capable of doing. So I think having this like wider consideration of things playing into this hackathon is especially interesting.
Yeah, so as a hacker, please take into account those judging criteria. So it's very important that your project is unique, that you don't just copy some existing solutions. The user experience and the user interface is very important. Like if you look at a lot of different Web3 applications, sometimes it can be hard to interact. And if you build something that's like very simple, that could onboard the next billion users. Composability, there's a lot of composability in Web3. So your project could be composable as well. That means it could be plugged into other like DeFi protocols or anything like that. And then the security, like there's different bounties and tracks, as well as workshops about security. So, so as I mentioned before, security is very important. And yeah.
I want to share here just a very interesting resource link that we have, which is a Scroll Hackathon builds repo done by our .role DJ Daniel Helm. This repo here basically has a bunch of hackathon projects that have hacked on Scroll in the last year. I think we're still missing out to add here Istanbul and India hacks, but in general, you'll find a bunch of ideas of what people has built in the past. This is a good reference if you're stuck and don't know how to, don't know what to hack. There's like a bunch of projects here that you can take some inspiration from, which is absolutely fine. Maybe build your own spin on these projects would be amazing. So I'll be adding this to the video description once we upload it, and also sending it over to the Hacker Telegram group. But in general, there's just a free realm. I did see someone asking earlier about what people could hack, and that's basically virtually whatever you want. So I also see, okay, can we submit multiple builds? That's a good question. Do you have info on that, Jan?
I would say it depends. Like if the code is created from scratch, if it's like a new idea, potentially you could submit 2 riddles, but maybe you could also consider to build like one project and apply for like several bounties.
Yeah. I think there's no issue with submitting different builds, but you also need to take into account, judging criteria. So I would wonder how much effort can be put into different projects for like one single hackathon. So we'll definitely, love to see it happen though. I also see a question here from someone asking about hacking with Noir and how to connect it to, the blockchain world, how to use the CKDSL and plug it into like a smart contract. So I'll be pinging the Aztec team to share some more additional info on the Telegram group. So please make sure to join that. Cool. So I think we take a small break before we head over to the next workshop with the Chainlink team. Are you good with that, Jan?
Yeah, I think it's good that we give our audience some time to digest all the info. I think it was a lot, like there were 3 different workshops. We talked a bit, and now there will be 4 more workshops from different teams. So I think it's best if we come back in like 10 minutes and give the audience some time to digest all the info and all the input.
Sounds great. Awesome. So I'll catch you guys in about 8 to 10 minutes. I'll see you guys in a sec. Peace.
See you guys.
Alrighty, and we're back at it. Now we have our guest here, Richard from Chainlink Labs, for the next workshop session. We're continuing strong. We still have 4 more workshops to go before we end today's workshop bootcamp. So yeah, Richard, how you doing?
Doing well, doing well. Thank you. Can you hear me? Everything's working?
Everything's working
Fantastic.
well. Everything's working well. So yeah, glad to have you here. You want to tell us more about what you're up to in Chainlink?
Yeah, so I'm a developer advocate at Chainlink Labs, and we've got a workshop talking about what is Chainlink, and we'll go through a little bit of hands-on if y'all want to follow along. If not, you want to sit back and relax, because it sounds like you've already had quite a few workshops. I'll try to keep it light. But we'll go through data feeds and how to use those, and yeah, talk about our track on this hackathon and all that fun stuff.
Yeah, that sounds super exciting. For the audience, in the meanwhile, if you do have any questions, feel free to drop them in the chat, and then Richard could answer them after the workshop.
Yeah, I'll try to keep an eye on the chat. I'll do my best as we go through.
Great. So are you ready to take it off?
Yeah, I think so.
Okay,
I'm
cool.
good.
All right. So let's hump out the stage, Jen.
All right. That's kind of, I think that'll work. Yeah. So like I mentioned, my name is Richard. I'm one of the developer advocates at Chainlink Labs. And I think probably the first place to start is by talking about what Chainlink is. But before we get into that, we need to do a few things. Hopefully the chat is active. I love interacting with the chat. There's going to be some questions for y'all. Hopefully you can get them right. They're not too hard as we go through this. So you're here at this hackathon. I'm assuming you all agree with this statement that Web3 is amazing, right? Like drop something in the chat, like give me a thumbs up, +1 if you agree. Web3 is awesome, right? It gives us smart contracts where we have agreements based on cryptographic truth instead of trust. We're distributed, decentralized, all of these amazing features. But Web3 has a problem. And that problem is consensus. So when it comes to any blockchain, the nodes within the blockchain need to reach agreement or consensus. And for some things, this is very easy. And I like to kind of go through an example. It's a pretty easy, basic example to kind of demonstrate where it can be a problem to be consensus. So we're going to run a little experiment. We are going to be a blockchain on this workshop. So, if you want to drop it in the chat, the answer to my next question, or if you just want to think about it in your head, we can do that. But I have a question for you. As a blockchain, can we come to consensus on the answer to this question? What's 1 + 1? It's not a trick question. Numeric values of 1 and 1. I'm not like adding strings together, anything tricky like that. Simple question. 1 + 1 gives me 2. Yeah, 2. Okay, cool. So we all agree that's 2. As a blockchain, we came to consensus. Easy question, easy answer, right? That's a deterministic question. It doesn't matter if I ask you tomorrow what 1 + 1 is. I think you'll probably say 2. If I ask, so I'm in Texas. If you are somewhere else, say you're on the other side of the world, like in Australia, and I ask you what 1 + 1 is, probably still going to be 2. So that's a deterministic question. It's pretty easy to come to consensus on a question like that. Now, I have a harder question for everybody. What's the current temperature? And I know I'm in the United States, right? We do this weird thing with the F, Fahrenheit. What is that? It's not Celsius like everyone else pretty much. But putting that aside, even dealing with Fahrenheit and Celsius, what's the current temperature? Well, it depends, right? It kind of depends on when I ask you that question, where you are when you get asked that question. This is a non-deterministic question. This is the type of question that a blockchain has a lot of trouble dealing with because all the different nodes within the blockchain are going to answer it differently based on those factors of when and where they're asked that, right? And that leads to a problem for blockchains. Now, this problem is about bringing real-world data, which is often non-deterministic, into a blockchain. And that problem is referred to as the Oracle problem. And that leads me to think of one of my favorite Disney scenes, Robin Williams, the genie in Aladdin. He talks about how genies have phenomenal cosmic power. but they have this itty bitty living space is the downside. And I think of blockchains like this. They have all of these awesome abilities and powers. We talked about smart contracts, the cryptographic truths that are decentralized, distributed, everything that makes them amazing. But they live in this itty bitty consensus based living space where they don't really have good access to the outside world. And that's very limiting. So this is called the Oracle problem. And I think it's kind of ironic that the solution to the Oracle problem is oracles. And that's what Chainlink provides. It's a distributed Oracle network. And we'll get to why distributed is an important thing here in just a moment. So when we think about oracles, I'm here in my office. Could I set an oracle up, just set a server up, leave it on my bookshelf, and bring off-chain data on-chain through a smart contract? I absolutely could. I could do that without a doubt. It would work probably most of the time, but that would then take the decentralized goodness that is a blockchain and effectively centralize it. So you have that single point of failure. And we don't want that. So you remember I refer to it as a distributed Oracle network? Well, what that means is that the Oracle network, so the DON or distributed Oracle network, is decentralized. All the different nodes within the Oracle network are run by individual entities and they're independent. And so they function in a similar manner to the blockchain. So you still maintain all of the benefits of the blockchain when we're bringing that off-chain data on-chain. And like I mentioned, this is what Chainlink provides, is that distributed Oracle network. So chat's not being super active that I can see. If you have any questions, feel free to drop them in the chat as we go through this. So one of the products that Chainlink offers and that is deployed on Scroll Network is Datafeeds. And what Datafeeds does is it provides access to, as the name implies, data from off-chain sources on-chain. Datafeeds is focused mostly on price asset pairs. What I mean by that is something like the price of ETH in terms of USD. So we have a price asset pair and what that is. So if you were to head on over to data.chain.link, you could see about Datafeeds here. We'll go into Datafeeds and we'll just pick the Scroll network here and filter them down so we can see what Datafeeds are available on Scroll. And I really like this dashboard because not only does it show you the trusted answer that's being reported by the Datafeeds aggregator contracts, but if we take a look at this, we can kind of start to see how Datafeeds works. So if we look down here at the Oracle data, each of these different boxes represents a different Oracle node. And I know the font's kind of small on these, they're pretty tiny, but if you notice, there are some variations in these prices, right? So like this one is $26.71. This one's $27.16. So we start to have an idea that like, yes, we're getting those different answers like we talked about, but how do we actually get that data and make it deterministic, right? So we're taking non-deterministic data, what's the price? And we can see here we have different answers to this. To make that deterministic, the easiest way to think about how it works at a high level is at a point in time, we have these values that are reported by the Oracle nodes. And if you take those values and you essentially think of them as an array, and then you say, what's the median value of this array of numbers? Now you've made a deterministic question, right? So we take a non-deterministic question, what's the current price of this asset? And we make it deterministic by saying, given this array of values, because each of the nodes submits that into an aggregator smart contract. The aggregator smart contract then says, hey, what's the median value of these numbers? So that becomes deterministic. So that's kind of high level how we take something that's non-deterministic through the oracles and make it a deterministic question, right? So that's high level how Datafeeds works. You can see here those different oracles. You can also see them down below. You can see they're all run by independent sources. So this is where we're getting our information from the oracles and bringing it on chain. So I'm gonna pause, see if there's any questions for just a second. All right, I'm gonna assume that everyone is on board 100% so far. Okay. So if we want to actually use data feeds in a smart contract, what is the best way to do that? Well, the best place to start is the Chainlink documentation. So if you head to docs.chain.link, you will see our documentation. You can see some of our other products. And if you hover over them, you can get an idea of what chains they're available on. So we're talking about data feeds today. And you can see it's on scroll. So we will go here. And this will explain what data feeds is and what's available there. Probably the best place to get started is getting started if you want to figure out how to use our stuff. So we'll go to getting started. And here it will talk you through what data feeds are, how they work, a few things. If you have never deployed a smart contract before, you don't have some sort of wallet like MetaMask or something like that, how to get started with that. I'm assuming everybody, since you're in a hackathon, knows something about blockchains. But we have a sample contract here. So let's talk through this contract real quick in Remix. So if we scroll down to the very bottom, we will see open in Remix. This is great. You click this, it takes you straight to Remix, which is a online IDE. I love Remix, especially for stuff like this, because it's very simple and very easy to use. It's all in your web browser, and it makes things quite nice to just kind of run through, because then you have to worry about installing anything. Make things a little bit bigger here. So yeah, let's talk through this contract really quick. We've got our license and our compiler version up here at the top. We've got our import for this aggregator interface. You remember when I was talking about data feeds that I mentioned that we aggregate those values together from all the different Oracle nodes? That's done here in the aggregator interface. So like this is how we interface with that aggregator. So this is how we're going to get access to that information. We have some comments here. It says, hey, you know, this is not production code. Make sure you know what you're doing if you deploy this to a real mainnet, stuff like that. And talking about if you're reading from L2 networks, we don't need to worry about that right now because we can just go straight to the contract. So data consumer V3. If you're following along, we will need to make one change. We could make two, but we really only need one. And I'll show you that here in a minute. So we have our data feed. That's our aggregator interface. You'll notice we have this comment here. This says, hey, this is for this Poly network. We're using the Bitcoin USD feed, and this is the address. So something to keep in mind when you're using data feeds is that each data feed is going to have its own address, and each address will be specific to a network. So that's something to keep in mind. We'll need to change these because they're set up for Sepolia, and we are not on Sepolia, right? We're on Scroll Sepolia. So we will get that changed here in just a moment. But this is in our constructor. So we're setting up that data feed. Now we're passing in the address here. And then we have a function called get Chainlink data feed latest answer. It's a public view and it returns an integer. So what this does is it goes out to the aggregator interface, gets the latest round data. So the last time things were updated, pulls that information back in, and then we care about answer. So that's what we have here. If you're looking at this and you're like, what is all this commented out stuff here? Fun fact about Solidity compilers. If you don't have all of these commas in here because latest round data returns all these different things, but we only care about the answer. So if you don't have blank spaces with commas, it'll complain because you're not accounting for all of the returned values. If you actually have values to store them in, then Solidity compiler will say, hey, you have all these unused values. So that's kind of what this is here, because it looks really weird if it's just comma, int answer, comma, comma, comma. Yeah, some fun Solidity trivia facts for you there. So this will get us back the answer, the value of Bitcoin in terms of USD. Again, I mentioned we need to change this address. So how do we do that? If we go back to our documentation, so this is at docs.chain.link, we went to data feeds, getting started. On the left-hand side here, we have feed addresses. We'll open that up. We'll go to price feed addresses. And if we scroll down just a little bit, we'll start to see all the different networks that are available, and we want to go to scroll. We'll go to scroll, and then on the right-hand side now, you'll see we have scroll Sepolia testnet. Click on that, boom, it'll take us down the page. And so we can choose Bitcoin USD. We could pick any of these if we wanted, but I'll be using Bitcoin USD. Give that a copy. We'll head back to Remix. We'll change this value here, and I'll change them in both places. Control D or Command D will let you highlight multiple things. So like if you hit just Control D or Command D, now we can change both at the same time. So I've changed this value to be our Bitcoin USD on scroll Sepolia. And we're ready to deploy. We've got a nice green check mark over here. If you don't have this, that means you don't have auto compile turned on. So you can just click compile or turn on auto compile in the compiler tab. We'll go to deploy. And probably the biggest gotcha, in my opinion, when I'm using Remix is I forget to change this environment, and it'll deploy just fine, but we're not on a real testnet. So we'll change to injected provider. You haven't used Remix before, it's going to prompt you to connect MetaMask at this point. I will make sure that MetaMask is on scroll Sepolia. It is, so we're good. And then we can click deploy. It'll ask us to confirm. We'll wait for it to show up down here, and boom, just like that, we have our data consumer v3 contract that's deployed with our view function to get the latest answer. We click on that, and we get this massive number. Now, if Bitcoin was this much, I don't know that I would be doing this workshop anymore, because that's a really big number for one Bitcoin. Another fun fact about Solidity is it does not understand the concept of floats or decimal places. You know, like, so there's no decimals in Solidity. So this value has been artificially inflated to give us more precision, right? So it's been multiplied by 10 to the 8th power. So basically our decimal point has moved 8 spaces over to the right. So if we come in here and we say 1, 2, 3, 4, 5, 6, 7, 8, and we put a decimal point there, that gives us a little bit better understanding of what is going on, right? So this is the response that's coming back now for what the price of Bitcoin is. So it's pretty fast, right? We blazed through this. We got Datafeeds deployed, and we've got our value back as to what the price of Bitcoin is in terms of USD. Just to kind of illustrate real quick, if I wanted to do a different asset, it really is just as simple as we take that value, we copy it, we come here, we paste it in, and then we need to redeploy this contract. Give it another deploy. We've got our second version here. And so this is going to be the price of ETH. Again, it's inflated by 8. Just kind of keep that in mind. So yeah, that is using Datafeeds, what Datafeeds is and how to deploy it. I know I kind of blazed through that. We still got about 10, 15 minutes left. So a few other things. I do see there's a question. Is there any way to add new data to the Datafeeds list, say for a list of physical assets? That would be something. So if you want to add something to the Datafeeds list, the available assets, for example, that would be more of a conversation with our team, and then also talking to the node providers, so the Oracle nodes themselves, because they need to be incentivized to do that. The way that they're incentivized is through paying them in Link. Datafeeds is kind of interesting because as a user, like what we're just doing now, right? I didn't actually interact with the Oracle network. They're doing stuff, putting stuff on chain, and I'm just benefiting from it because once it's on chain, I can read it. So Datafeeds, which is what's currently on scroll, is like that kind of push-based method. We also have another product called Data Streams, which is a poll-based method where you actually ask the Oracle nodes to give you the price now, and you pull that onto chain, and you actually pay them Link directly, like some of the other products that Chainlink provides. You pay directly for those services. So that's a great question, though. Yeah, there are other products that we have too. Unfortunately, not on scroll currently, but that maybe for getting a list of physical assets would be a better fit for that. So yeah, with that, that's kind of like the high level demo of things. I would say where to go from here. Like if you're having trouble, questions, comments, we have a Discord community that's very active. We also have starter kits on GitHub that will let you get started if you're looking to build something bigger, which, seeing as you're in a hackathon, you probably are. You're probably not going to be using Remix for everything. So if you're using something like Hardhat, Foundry, we have starter kits to get you started with those. We also have our documentation that I went through, and we saw a little bit of that while we were going through this. So yeah, if you have questions there, and there's always like Stack Overflow or Stack Exchange. I love it when people ask questions on those. Like our team actively monitors those platforms as well to help out, because the fantastic thing about something like Stack Overflow or Stack Exchange over Discord is if you have the question, someone else probably has the question too, and then they can find it when they search for it, which that is fantastic. If you are going through these things and you needed some ETH or link to do anything, if you go to faucets.chain.link, I guess I should have probably talked about this before I went through the demo, but if you need some ETH, you can go to faucets.chain.link. Here you can get link and ETH from our faucet. And then, yeah, as far as the hackathon itself goes, so for this hackathon, we have a bounty of using data feeds on Scroll. So it's total value of $10,000. We're going to do 5 of the projects, like 5 best projects that are using data feeds. We'll each get $2,000. So it's pretty awesome. Basically, though, you do need to use data feeds in something that makes a state change to the chain. So what does that mean? If we look at this example, when I used data feeds, it's just viewing the data on the chain. This would not work, right? I'd need to actually use the data feed and then make a change to the blockchain itself. So hopefully that makes sense. If that's not clear, let me know in the comments and I can try to explain it a little bit better. But essentially, you need to write data on chain that has used data feeds. It's probably the easiest way to think about it. Yeah, and it kind of talks through those requirements here and what our judging criteria are as well. So yeah, we always look for things like the UI, UX, DX, whatever it is, that you used technology in a way that was valuable. And then a wow factor is kind of like that if it's just awesome, it makes us go, wow. That's what we're looking for there. And then I will say too, you're in this hackathon, that means you're probably one of those people who likes hackathons. And if you head to hack.chain.link, we have a hackathon starting soon that you can register for as well. If you want to just kind of keep that hackathon juice going, that would be awesome. So yeah, hack.chain.link or chain.link/hackathon, whichever way you want to put that in. And yeah, that's about all I got, unless there's questions, comments, cries of anxiety when it comes to hackathons, anything like that.
We surely will get more questions as we go, probably on the Telegram group. Not sure if you caught that, but we are hosting this globally in terms of localized meetups goes. So exciting to see that how that works out. We're gonna get definitely a lot of inbound from these hackers meeting IRL to to hack on this hackathon. Let me bring Jan into the stage here. There you go, Jan. What's up?
Yeah, great presentation. Maybe you could share a bit more about the bounties, like what you would like to see from hackers, what you're excited about.
Sure. When it comes, I try not to put too much flavoring on what I'm looking for, just because I feel like that sometimes can limit people's creativity, right? So when it comes to the bounties and what we're looking for, it's definitely going to be, and I think that you just were mentioning this, but as I joined, I was sitting backstage, but like things that haven't been done like a bunch of times before, right? Like if it's a project that already exists out there, and you're just kind of like recreating it with your own, like a little bit of different flavor, that's probably not as like impressive of a project as something that's new. So new applications, solving problems that currently aren't solved, I think is what we look for the most when it comes to those projects that really stand out. And I think also having that extra polish on like the UI and the user experience definitely goes a long way too. Because an awesome smart contract backend is great, But if it's not something that people can actively use easily, not as great, right? And it just depends on the project too, because I know there are some like backend projects that are fantastic that enable developers to do amazing things, and that's another way to approach it, right? It doesn't always have to be all I don't know how to differentiate user, but like typical user in the space based. It could be something that enables developers, and that's also really, really powerful and really useful as well.
Okay, I think that's pretty good insight. So developers and hackers, please build something that's unique, new, and also has a great user experience.
Yeah.
Absolutely. Well, great. Thank you for sharing about Chainlink. I have been shilling a bit about the Chainlink hackathon earlier today, so excited to join you guys there as well, getting everything set up. But excited to see that hackers they're very entertained for the next couple of weeks for sure. They have a lot to play around with. So yeah, excited for this one and the next one.
Yeah, absolutely.
Cool. Well, thank you, Richard. I think we'll be going into a small break before we go to our next workshop with Edge and Node, aka the Graph. So thank you for joining us, Richard.
Yeah, absolutely. It's been a pleasure. And thanks for everybody who's around and gave me some of your time to listen to me talk. And I look forward to seeing your projects.
Absolutely. All right. Bye-bye.
Bye.
Bye-bye. See you in 2 minutes.
Okay. So we'll go into this very short break and we'll be right back.
Yeah, next up is the graph. So I'm also excited about this one.
Awesome. Be right back. Alrighty, we're back once again. Hello there, Marcus. How you doing?
Very well. How are you doing, Juan?
It's great. It's great to have you here. This is our, let's see, sixth workshop of the day. Yeah. Okay. So this is the sixth lot of the day. Definitely happy to have you guys here on board, not only on the stream but also on Vortex. Definitely a fan of the graph and all you guys do. So excited to hear what you got for us today, Jen.
Yeah, like I'm also quite looking forward to learn more about the graph, how to query the free data, and learn also more about subgraphs.
Awesome. Yeah. Well, I'm very happy to be here today. And I'm going to go through a workshop exactly as Jan, you just said. We're going to be learning how to query Web3 data and really understand the graph and how to interact with it. And that's actually part of our bounties here. You guys can see my screen. We've got the best new subgraph as a bounty, and then best use of an existing subgraph. And this workshop is specific to the best use of existing subgraphs. And so we got the prizes here and description. Feel free to read through this, understand the bounties even more. But this is really what I'm going to be walking you through here. Best use of existing subgraphs and just really understanding the graph network as a whole. So, and yeah, my name is Marcus. I do dev relations for Edge and Node, and Edge and Node is one of the core development teams working on the graph. So let's get into this presentation right now. This is querying Web3 data with the graph. And for the repo for this project, let me actually just share this with, bam, if you can actually share this in chat. This is the repo for this project. Okay, so you guys will be able to follow along with the code and actually integrate with the project with this repo pretty easily. There's vanilla JavaScript code in this repo, Python, Apollo also being used, and then Graph Client, which is built from one of our core development teams specific to query subgraphs on the graph network. It's got a lot of cool features in there. And then also we're talk a little bit about playgrounds and DAppLooker. We'll talk about that later. So everything good to go? Screen can be seen. Everyone feeling all right? All right, let's get into it. So this quote, I think, really is appropriate for the graph. It is not the answer that enlightens, but the question. The graph is a place where we can get the answers, but really curiosity, I think, is my favorite emotion of all the emotions. If I could be curious, I'm very happy. And I think that's where a lot of fire comes from everyone around the world. So curiosity is what I really want to bring up today. And then if we have that curiosity, we can then have that motivation and energy to go out and find the answers. So the graph is going to be there for you. For those of you who don't know what the graph is, let's go over a high-level overview of what the graph is before we get into things. All right, so let's just back up a little bit and talk about the blockchain as a whole. The blockchain overall is write optimized, which means anywhere around the world we could write to many blockchains. And from here, we can go ahead and say that transaction was made. And from there, interact with the smart contracts. And there we go. It's in the history of that smart contract, which is great. However, it's horribly disorganized. It's all just based on whoever actually pays the gas fees and gets there on time. And it could be from one person from completely opposite side of the world and another person interacting with a different dApp. As long as they're on the same chain, it's just going to be just organized by timestamp and whoever gets in there. So with that, because of the disorganization, indexing is required, and indexing really is just organizing the data. So what we have here is a situation where, okay, we have a lot of writes going on in a disorganized way, and we need to index that data. And indexing, traditionally done before the blockchain, was very centralized, and it has a lot of different options for actually just having an indexer and a database and populating that database and running the index through and just really making sure that data is organized. Well, that's a problem, essentially, because that centralized indexing creates a kind of a Web 2.5 read solution where we have all this disorganized data going through a centralized indexer. Well, we have a problem then, where essentially we have all the advantages of Web3 being mitigated and pushed through a centralized solution, where very much so, we are trying to get away from that in Web3. So The Web3 read solution is very much the graph, where there's decentralized indexing done by indexers on the graph network, and all of those indexers are permissionless. You, me, anyone out there can go ahead and build on the graph and become an indexer on the graph and start contributing, and incentivized with the graph token. The GRT work utility token is specifically meant to incentivize indexers and earn returns on their indexing and querying capacity, being able to provide responses to those queries. So that's really the graph protocol as a functioning tokenomic model, and is working very well in the Web3 ecosystem to provide indexing in a decentralized way, where if any of those indexers do go down for whatever reason, there's many backups behind them. So essentially, that's it. That is the graph, the decentralized indexing and querying protocol. There's 150 plus indexers worldwide that are permissionless. Like you and me can just hop in, as long as we got some hardware and we understand indexing and learn the stack, we can go ahead and do that. There's redundancy, like I said, fast, cheap, and reliable. Right now, per million queries, it's $40. So very reasonable pricing for 1 million queries on the graph network. And it's also a global open API. These are actually public goods, all of these endpoints that are available. We'll talk a little bit more about those endpoints, also known as subgraphs. They connect to subgraphs, and we'll get into that right now. So subgraphs are, I mean, I'm talking with developers right now in Web3, so you probably have heard of subgraphs before. Just really quickly, let's go over what that is if you don't know what subgraphs are. Essentially, they're customizable APIs. And the graph, years ago, was the original protocol that came up with subgraphs. Now subgraphs are being used throughout Web3 as a whole. But essentially, if you can see that little arrow right there, if we have all the different chains here, scroll included, and we have all these indexers indexing the data, well, these indexers need to have instructions on what type of data they want, what type of data, we want as developers, as builders, and we have to send those instructions to the indexers around the world and say, hey, which of you indexers want to claim this subgraph? And once they claim it and they say, hey, we'll start indexing the data in the way that you'd like, then we can send queries to that subgraph through that endpoint. So essentially, we have to design these little arrows right here and say, hey, if we're going to be getting out there, let's go ahead and design these little subgraphs. And from there, we understand that subgraphs are an API, and then also subgraphs are valuable because, like I said, these subgraphs are a public good. These indexers around the world are all indexing these subgraphs, and they're available on the Graph Explorer. And anyone can actually send queries to these endpoints so their front ends could be populated. So that's pretty cool. Let's just go ahead and take a look at this here. I love this GIF. It's very simple. When a subgraph is built and deployed to the graph network, it actually organizes the data just like this and puts into little buckets, also known as entities. And from there, we can send queries to the entities and their fields and get the data back. And that's all it's doing. It's just a subgraph are customizable instructions that you or I could build, send those instructions to the indexers around the world, and indexers can claim those instructions and say, we're going to go ahead and index that data for you and provide the query responses for you so you could have your DApp be populated with valuable information. Okay, so diving one step deeper, we're going to actually look at the file structure of a subgraph, the 3 most important files. We have on-chain data and off-chain data. The subgraph is also able to index data from IPFS and Arweave, so that's pretty cool. We can get some files in there. But really, there's 40 plus chains, including, of course, scroll in there. And these are the 3 most important files. There's the manifest file, and then there's the logic file, also known as the mappings file. And then there's the schema, or the GraphQL file. And this right here is the database from which we're going to be sending our queries to. This logic right here in the mapping is really, if we're going to be doing any transformations, that's going to be important to understand, well, if we're getting just log data, if we're going to log data from the blockchain, we're not going to do any transformations. We don't really do anything here. But if we're going to transform data from our smart contracts and their events, we'll need to do some work here. In this presentation today, we're not going to go over these 2. We're just simply going to go over, we're not going to go over the manifest and logic, the overall effect, the deeper parts of the subgraph. We're just going to go over the database because we're going to be sending queries to our subgraph's endpoints. And that subgraph's database itself is organized in the schema.graphql. So we're just going to go over that really and just understand that a little bit better. So and I said also subgraphs are valuable. If you guys want to check out the graph.com Explorer, Every one of these subgraphs are on the graph network, which is the decentralized network of indexers around the world. There's 1,700 subgraphs here, and that's being incentivized by the GRT work utility token on Arbitrum 1. And these are the subgraphs being incentivized on Ethereum. So we have 994 on Ethereum. So all of these are endpoints. Each of these are databases we could send our query to. And these are all subgraphs. And so this is pretty cool. All we have to do is really go through the steps of learning how to send queries to all of these valuable pieces of organized data. We have Uniswap, ENS, Lido, UN, CX, lockers, BetSwirl. I mean, these are all bits of organized data that we all have public endpoints that we can go ahead and click on any one of these. And then from there, send our queries to this endpoint. Okay, so just an introduction to the graph as a whole. The first thing we really have to do is set up an API key to send queries. If we send up an API key, this is very useful for hackathons. We have 100,000 free queries per month that we can send in to the graph network, and that's going to be part of this for this hackathon, building off of these subgraphs that are already in existence. This is already part of the prize. All you got to do is start sending queries. You got 100,000 queries on the graph network that we could send. And let's go into these steps to query a subgraph. So like I said, first things first, we're going to set up an API key. We're then going to go a little bit deeper into assessing a subgraph on the Graph Explorer. Specifically, we're going to understand a little bit what is well-organized quality subgraphs, and we could actually tell just based on a few different factors. And then from there, we'll actually design a few queries on the subgraphs playground where we could use GraphQL to send queries to the subgraphs database. And then we'll learn just the high level of how to integrate the query with a DApp. So let's go ahead and set up an API key first. And we'll do that right here. All we got to do, we'll start with thegraph.com. And we'll go to products, subgraph studio. And from here, we'll do API keys, and we can go ahead and create an API key. We'll name this the scroll API key demo, and that's it. So from here, all we have to do is take this API key, and then from there, taking this into the Graph Explorer. And remember that endpoint that I pointed you guys to, just simply going through and dropping that API key into that query endpoint right there. And then we could actually start sending our queries to that. So it's very simple in our application. Let's keep on going after we set up the API key into the next step. So we're going to find and assess a subgraph on the Graph Explorer. And I remember first time getting introduced to the graph years ago, where I really enjoyed just understanding, okay, well, what is blockchain? Just learning a lot, being curious. Like I said, I jumped into CryptoPunks and I really wanted to learn more about CryptoPunks. And so I said, okay, well, how do I figure this out? The graph was there to provide me data for that. So I want to go back in time for me and see how that looks. And if we could just walk through CryptoPunks subgraph specifically, let's go ahead and see how that is with finding and assessing a subgraph on the Graph Explorer. We're going to do that, and we're going to see, is it a Masari standard subgraph? We'll talk about that, and we'll see what that means in a little bit. Also, we'll look at the curation level of that subgraph. We'll look at the documentation of that subgraph, and we'll see, okay, are all these things looking nice so far? And then from there, we'll look at the schema GraphQL comments. Remember I said we're going to look at the database, which is the schema.graphql. This is kind of the order that I like to go through and understand if a subgraph is quality, or if it's maybe just kind of like a beginner subgraph, and that could also be quality depending on the quality of the smart contract. But if it's a more extended subgraph and has more features, essentially, that's what we're going to go through and see if there's more compute in that subgraph or if it's more basic. So let's do that right now. First, we're going to see, is there a Masari standard subgraph that looks at the CryptoPunks smart contract? Let's go ahead and do that right now. So we'll go here, we'll go to Graph Explorer. And we'll type in CryptoPunks. And so right now we see we have a Masari standard subgraph. So what does that mean? Essentially a Masari standard subgraph. We'll do Masari subgraphs. Masari is another core development team working in the graph ecosystem, and they are writing beautiful, really extended, lots of features subgraphs. And they also have worked very hard at having nearly all of these schemas, all of these databases are very much standardized. There's a few differences here and there with some of these databases, but for the most part, all of these bridge subgraphs are standardized. All of these derivatives subgraphs are standardized. The exchanges, which is the biggest category. So if we send a single query to any one of these subgraphs and also send that exact same query to another subgraph, we can compare that data, the data points coming back from those 2 different subgraphs, or 3 different subgraphs, or 10 different subgraphs, which really, if you think about it, we could look at HoneySwap, OsmosisDex, we could look at QuickSwap, we could look at ApeSwap, look at Curve, SushiSwap, Uniswap, look at all of these different swaps, send a single query to all of them, and then do compute on that when we get that back. And if we could think just for a second on all that DeFi data in terms of actual decentralized data coming in from all these decentralized swaps, from all these exchanges, that's a really cool use case where we can get a little creative and ask some interesting questions, saying, okay, well, if this Masari subgraph from Uniswap and there's a TVL there, and then let's compare it to a TVL here, or we could actually see different pools and compare those different pools. There's some pretty creative ideas we could see and go from there. So that's Masari. All of these subgraphs are going to be quality subgraphs to send some data to, and I'll explain a little bit more about what that means with quality. Any one of these have good curation, good documentation as well. So that's the first thing I look for. That is this subgraph, like I said, and we could send queries to this subgraph, just go to the playground and start playing around. I want to take a little deviation and say, okay, if we already know Masari is quality, let's just assume this subgraph doesn't have a Masari tag on it. It's not a Masari subgraph. How do we know if it's a quality subgraph or not? Well, we got to go a little bit deeper because we can't just look at it for face value. This is a core development team in the graph ecosystem. They're going to be good subgraphs. Let's look at another one. This one right here has 2K GRT on it. Remember I said there's the incentivization, the GRT work utility token in the graph ecosystem? Well, that's it. The more GRT is signaled onto a subgraph, the more incentivization there is for indexers around the world to jump in and get a return on that GRT. So we could see with 2K GRT, we have 8, 9, 10, 11 indexers indexing this subgraph. It was deployed 7 months ago, last updated 7 months ago. This is good. It's a little bit of GRT on it. We have good amount of redundancy. If any one of these indexers go down for whatever reason, the power goes out or something, we have backups, and that's going to be helpful. So all of these queries are able to get through. And then from there, remember I said the next thing we want to look at after looking at the curation, which is the signal, we have the 2K curation on that, is actually the code and the comments in there. So let's go ahead and see this subgraph one level deeper to see if this is a quality subgraph. So do we have some good documentation in the subgraph? And yes, we do, which is very nice. This is just good code smell. We're able to see which contract addresses this subgraph is looking at. We could run a local graph node if we want to locally index this. We could totally do that, or we could index this on the graph network. That's totally fine. And it's also giving a little bit of understanding of the logic that's going on in the subgraph, a little bit of the compute that's going on in the subgraph, which is really nice. So from here already, thank you, this developer, Jerry Okolo, for developing a nice subgraph for us. The next level deeper, and really if we're going to query a subgraph, this is the only next level deeper we need to go to, is go to the schema.graphql. And this is what I mean by the organization of the database and the comments. If we send any queries to, we're going to look for an entity here. We have a type account entity, and we have a comment on top. This is very nice because sometimes deeper in the subgraph, in the mappings, or in, well, it would be in the mappings, they are going to be populating the ID. This bytes right here, this ID, account ID of type bytes. If there was no comment here, we would not know potentially what this bytes, what this ID would be. And now we know this is the Ethereum address of the account. Thank you for writing a comment here, subgraph developer. If we sent a query to the account entity and it was just assigned, all we would see is we're sending a query to account assigned. What does that mean? Well, it's the punks assigned to the account, if any. Thank you, subgraph developer. We don't have to go deeper into how to build a subgraph. We could send our query right away to the account entity of the assigned field and get this data back from that. And that's very nice. So we don't have to go into the mappings. We don't have to go into the subgraph.yaml. We can if we want to learn more about subgraph development, but we just want to send a query and get some data back. Okay. So that's really what we have. Going through these comments of the schema.graphql of any subgraph, the Masari subgraph all have comments, by the way. That's always very nice. It helps us understand what data we're getting back as opposed to just strings or numbers back. So go through these comments, understand how they're organizing the data, and then from there, we're ready to go. So got 10 minutes. We're going to keep on going here, guys. So let's get into it. We have gone through understanding a Masari standard subgraph. These will all also have comments. We went through subgraphs.xyz, which will go through all the Masari subgraphs, a lot of well-organized data. We looked at the curation level, how much actual GRT is in the subgraph. We looked at the documentation of the code, which is always very nice if the subgraph developer puts some documentation for a high-level understanding. The only file we really need to look at is the schema.graphql comments. From there, we could start launching out those queries to the endpoint. So first, we'll actually learn, before we send out queries to the endpoint, of designing GraphQL queries. There's filtering, there's logical operators. We could also save queries, and there's lots of more features in the docs if we want to. But first, what I want to do is let's think of some example queries that we could send, some questions that we could send to this subgraph. So let's think of some interesting questions. And these are basic questions. Feel free to get more creative because there's many other questions we could ask, but we're just going to go through and learn how to use GraphQL real quick, at least in the playground. This is the first one I wanted to do, the first 10 sales in CryptoPunk's history. Let's go back to history and think, okay, well, what are the first 10 ones ever? And then the first 10 sales between this timestamp, January 1st, 2019, and this timestamp. First 100 sales right there between, these two timestamps. And then also, what is the total value of all sales, the total supply, and the total number of sales on the CryptoPunks contracts? All right, so that's going to be a little bit of compute potentially, because if we think about it, they're probably not going to be doing, that compute, which involves a lot of history in the smart contract itself. They'll probably do that in the subgraph, and we can see here. This is an example of subgraphs compute, and that is just a nice thing that subgraphs can do. We're not going to show you how to do this in this, but if you ever do see entities and fields that have what seems to be some mathematics in there from history, just know the subgraph is powering that, and there's some different mathematics that can be done. So let's go ahead and figure out the first 10 sales in CryptoPunks history. Let's go here, and we'll go back. There we go. And we'll go to the playground. This is GraphQL, totally okay if you haven't used it before. From here, we just go to this little folder, and we can see all of the different entities that we could go ahead and see. And what we're looking at is sales entity. And every single entity ever defined in a schema has a singular, which is a single sale. And from there, we need to populate it with the exact ID. So it does help to know what the ID is if we're going to send in an exact query. So we have to go back to the schema and see what that is. But we want the plural. We want sales, all right? We want the first 10 sales. And you can see it actually just populating right here. Very easy just to click and just see what you want. Now, what we want here, I always like to get the ID because that's going to be helpful if we ever want one specific sale. And we want to know the first 10. So we need to get the timestamp. If we want to go deeper, we can get to know who is it from. We can know the exact contract we're on here. We can know who it's sent to in this sale. We can get to know the amount, but we're just going to look at the ID and timestamp because that's the question. And we want to order the direction and order by. All right, what do we want to order it by? By the timestamp, because that's going to be an order by timestamp. And then we can just send the query right there, and then we're able to get the data back. Okay, so very easy, just drag and drop, start clicking around. And if we ever are looking at any of these entities right here, remember, I'm going to make my screen a little bigger. Let's see if you can see this. There's a little pop-up right here. If a actual field on an entity has a comment, just hover your mouse over that field and you will see, hey, there's the comment. This is, if you click on the NFT, this is the punk being sold. It populates over there, and then we can actually keep on going and fill out the ID and see from there. So the NFT ID, this is 544. And what is this ID? This is likely going to be the actual token ID right there. So, so that's just cool to know. More rich information here. Now, once we have this query, all we got to do is copy this query and send it to the endpoint. There's the query endpoint right there in our decentralized application and populate the API key, and we're already building. So that's pretty dang cool right there. And then from there, what I want to do is I'll leave. If you guys got that repo I put in there, this presentation is in the repo. We only got 5 minutes left. So I'm just going to say, hey, if you want a homework query, go ahead and play with this and specifically the where filtering, because what we have here is the sales first 10, we could say and the where, this is the logical operators. So amount GT greater than, amount greater than or equal to, amount less than, inside, less than or equal to, not in. So these are the logical operators, and we could actually build out more of our query. And so for this one, of course, we would do timestamp greater than, and type in the timestamp less than. We could really start to do some good filtering and some logical operators and organization, and ask some really good questions with our subgraph. So it's pretty cool. So from here, what I want to do is the last thing I want to show you real quick is finding the TVL on this exact date. We have these standardized Masari subgraphs and this exact query. This is really powerful. I've seen some teams do some really cool stuff with Masari subgraphs. These are the two standardized subgraphs. These are both exchanges. We have curve and we have sushi swap. And I'll take this query and I'll say, hey, let's go ahead and look at these two subgraphs. This is curve on the graph network. And I want the TVL between this time on curve and the sushi swap. I want the curve as well. I want the TVL there. And we can get that data back right away. And we can compare those two communities, those two different exchanges, and say, hey, we're able to design something very cool with that. So with that being said, if you want to get even deeper, we've got another homework query. This is all in the repo that I shared in that link before. If you're sending more advanced queries, potentially with lots of nesting, that could cause some issues with queries where they're just going through a database with lots of logic and lots of different types of queries. It does help to learn a little bit about GraphQL and their optimization of the queries. So go ahead and hop into here. And also, if we want to send queries using Python and go ahead and do some maybe machine learning, some AI on the different data that we're getting back, this is Playground. So if you like to use Python, go ahead and hop into Playgrounds and Subgrounds. And this is DAppLooker. If you want to just build a dashboard without actually coding the front end, you could use DAppLooker, which allows you to send queries to a subgraph and get that back, and automatically populates these no-code dashboards, which is pretty cool. Takeaways, think of great questions. Really, that's a really big part of the graph where you got to think, okay, which community do we want to go into? How do we find the subgraph? How do we assess the data? And then from there, send those queries after getting aware of the schema. Decentralized indexing, it's really truly decentralized. So that's a big deal when you find subgraphs in the Graph Explorer. There's 2,500 subgraphs already ready for you to go ahead and go through and see what data is already organized. You don't have to build a subgraph. It's already waiting for you. The Graph Explorer is a wealth of information. Play in the playground with your 100,000 queries free per month. Plenty for this hackathon. And this is, once again, the repo and DApp integration, drag and drop code. All you have to do is replace the API key with the API key that you have. And then from there, you're ready to go. And if you want to join the hackers group, this is our hackers group. I know there's a Scroll hackers group as well, so I'm not going to hold this up too much. I think you should just join the Scroll hackers group. I'll be in there. And then also, this is the Builders newsletter. I write this every single month for anyone interested in learning subgraphs and wanting to learn new features of subgraphs, new news in the graph ecosystem. This is what I write. So if you're building a smart contract and want to integrate with a subgraph very quickly, read this article, Build, Adapt Quick with the Graph and Scaffold ETH2. This is for those of you building a smart contract and want to actually build a subgraph as well. This is a really great blog to get you started with that. So with that being said, I know we only have like 1 minute right now, but I'll just stay around here for any questions.
Coming here on stage with you, Marcus. Thank you for sharing about what's building on the graph. Very exciting. It's interesting to see what's a good subgraph. Cool. Interesting to take a deeper dive into that. So yeah, particularly excited to see what comes out of this hackathon on what people use the graph to hack. Something I've mentioned it a couple times, but it's a long stream, so I can keep repeating it. something I'm especially excited about is these local meetups we're hosting worldwide to incentivize new hackers, maybe in like, emerging market region that haven't had the opportunity to participate in a hackathon yet to, touch all these great technology. So exciting to see, new people messing around with all this stuff.
Yeah, for sure. Absolutely. Well, thank you guys for having me. And if there's any questions, I'll be in the Telegram group and here to help out the hackers. I'll also be judging
Awesome.
too.
Yeah.
Great
Jan,
presentation.
yourself?
Forward to seeing all new subgraphs getting built, but in this hackathon, and also more use cases of existing subgraphs. As you mentioned, there's a ton of existing subgraphs. So very excited to see all those use cases.
Awesome. Awesome. Yeah, same. And if anyone has any questions, you could find me on Twitter, Marcus_Rain_. Happy to help out with any subgraph questions. Also with Telegram, just if you're building a subgraph, reach out. I could help with actually building that as well.
Great. Cool. Awesome. Well, thank you, Marcus. We'll catch you later.
Awesome. All right. Take care, everyone.
Thank you.
All right. And Jan, we go into a quick 2-minute break. We have Harris from Covalent already in the backstage. So we'll take it. We'll take a 2-minute break and be back.
Sounds very good. Be right back.
All righty. Alrighty, and we're back at it. 7th time of the day, Jan.
Good to be back.
It's been a minute. It's been a minute. Harish, welcome in. How you doing?
Doing very well. How are you guys?
Excited. It's been a long day. Let's see, 6 workshops so far. This is the 7th one, so a lot of insight, a lot of stuff building on Scroll. So particularly bullish.
For sure.
Likewise.
I've been watching some of the other presentations. It's been pretty awesome. And you've been doing this back to back. So kudos to you guys and also to the audience for listening in and following along. Pretty exciting.
Absolutely.
Yeah, developers, they have the chance to also watch it asynchronously, so they can take breaks and rewind if needed.
Mm-hmm.
Great. So what are you going to talk to us about today, Harish?
Yeah. So I just want to maybe caveat this presentation with a couple of things. One, obviously love the Scroll ecosystem. They've been fantastic ecosystem partners of ours, and you know, when you guys reached out about participating in this hackathon, we were pretty eager to jump on board and support you guys, and also seeing some of the other fantastic projects that are a key part of this. So thank you for that opportunity. And secondly, I want to talk a bit about some of the tools that we've got for developers, especially in the context of a hackathon, how they can build their applications rapidly using some of the tooling that we offer. So that's going to be the predominant focus for my my workshop today.
Great, awesome, absolutely glad to have you guys here. I know that we have some other things going on together. So yeah, definitely, you know, nice working with the Covalent team. I do want to give a shout out to David there. He's such an amazing guy.
Everybody
So,
loves David. To make a show about it.
oh my God, man, he's such an amazing dude. But yeah, I think we're ready for you to take it away.
Yeah, go ahead.
Awesome. Okay. Thank you. Perfect. The screen's up. Let's dive in. So welcome, everyone. Thank you again for the opportunity to talk a little bit about some of the hackathon-specific toolkits that we've got. Especially, you know, with the relatively short time frame, you want to be able to build quickly. And so the focus here is how you can build your UIs with something that we call GoldRush Kit. There's a link to the repo here, and I'll also share it shortly so that any of you wanting to follow along in real time can do so. My name is Harish. I look after DevRel at Covalent. And for those of you who may not be familiar with Covalent, we're a pretty broad-based on-chain data provider. And so by broad, I mean, you know, we obviously support Scroll and, you know, the main net and the various test nets, but we also support over 200 chains with the emphasis on providing developers with tools that make it very easy to incorporate on-chain data into their builds. And so we'll talk about a few of the different ways that you can access this data. But first, I just want to talk a little bit about, you know, what are some of the challenges that we're trying to address. And so if you look in the context of, you know, on-chain data accessibility, you know, there's blind spots everywhere. And I've been in this space since 2017. So kind of seeing the evolution of the projects, the protocols, and effectively the complexity of, you know, these transactions happening on chain highlights that, you know, with various ecosystems having different ways of presenting this information or even recording this information, it becomes very challenging very quickly to do this across chains. So you got all these blind spots. We've gone from this, you know, with the growth of the Web3 ecosystem from very basic, you know, token transfers to, you know, multi-chain hops with DEX aggregators doing all sorts of interesting and complicated transactions. So that's the world that we're in now, and being able to access this data in sort of a meaningful and easy way continues to be a key challenge that we're trying to address. Data availability, again, with the rampant growth in the volume of data, being able to go back to the Genesis block for, you know, every single chain that we support highlights, you know, the fact that we've got something that anyone can access as a public good, going back to the very first transaction on Scroll and every other chain that we support. There is you know, this key challenge where if you're trying to paint the picture of what this transaction represents, and you're looking at something like an NFT, you know, there's elements of that data that actually don't live on chain. So it could be everything from, you know, the sales or the marketplace data around bids and offers, or the listing. It could be with the metadata. It could even just be the image asset that lives maybe in IPFS or somewhere else. And so being able to quickly have access to the key fundamentals for this primitive is, again, another challenge and something that we try to directly address by caching a lot of these key NFT data sets. We'll find that even with the same protocol across multiple chains having a slightly different semantic or different way that data is stored. And so putting all this together, blockchain data is messy. It's, can be difficult to access. It can be difficult to access at scale. These are all fundamental problems that Covalent is trying to address. And so that brings us to introducing this GoldRush kit. And so fundamentally, we're an on-chain data set or a database that has access to every on-chain transaction since Genesis block. And then we've got a few different interfaces for accessing this data. And GoldRush Kit is essentially a set of front-end React components that allow you to visualize on-chain data, and more importantly, be able to take these customizable components and effectively embed them and incorporate them into your application quite rapidly. So you can focus on, building your application and delivering value to your users, and not so much on the actual, process of trying to fetch on-chain data. That's effectively the service that we're offering. So when you look at the suite of tools that we offer developers, fundamentally, Covalent's a database. We've got our unified API, which offers a various set of endpoints for being able to access on-chain data. And then we've got, tooling for building out front ends with GoldRush Kit. And then we've also got something like a BI tool. So if you're familiar with, Dune Analytics or some of these other charting and reporting tools, there is a product suite built basically around that capability. So you might be asking, well, why another kit? There's plenty of them out in the ecosystem. Lots of good ones, I would say, as well. And so I think we bring an element of uniqueness to the table with the fact that we've got a pretty broad range of chains that we support. This toolkit is open source and completely customizable. And effectively, what we're going for here is interoperability. So we can actually work pretty seamlessly with many of these other kits highlighted here. So it's another kit into the ecosystem that works with the other tools that exist, and it allows you to be able to just do things faster, more efficiently, and that's really the essence for bringing about another kit. Plus, having sort of this front end visibility is actually quite useful for us. Being an API provider, for the most part, having something that's headless, it's kind of hard to visualize how this data actually gets used by applications. And so having something like a UI kit allows us to see how a developer would want to actually present some of this on-chain data, and it actually serves as a great debugging tool for us as well. The way we've gone about building GoldRush is to look at it from perhaps the most modular way that we could, and leveraging a framework employed by Brad Frost, which is this concept of atomic design. And so we've taken these fundamental components, these very primitive components that we call atoms. And so this would be like how you might render a particular wallet address. It could be how you render a particular token. And then you kind of take a few of these atomic components, and then you can put them together to build something akin to a molecule, which is a little bit more of a comprehensive component. And then you just keep building using the chemistry analogy into something that morphs into an organism, where these could be cards that render data that you serve up through these molecules or atoms. And then combining these organisms together gives you templates and pages that really provide the rich value components that you want to use into your application. And so by doing this, what it actually means is you could go and customize everything from the template or the page right down to the individual atomic component of your icon or the way a particular wallet gets displayed. So it's incredibly customizable, built by design using this atomic design framework. So that's enough sort of talking about the kit. Let's actually dive in and see how it works. So this is the open source repo, and maybe I'll just paste this into the private chat as well. And maybe Juan, you can paste this over into the public chat here. So we've got our GitHub repo, and just talk you through a few things that are presented here. One, the setup super easy using npm or yarn. There is this element of the GoldRush provider that needs to get configured with an API key. And again, the key is absolutely free for you to get set up with. And then we've got a couple examples. So this is actually a pretty comprehensive one where you'll get to see everything from a token view to a token transfers view to a list of all the chains that a particular wallet address is active on with this address activity. So you can literally just copy and paste this example and run it and get a quick snapshot of the various types of components that we have. There are templates that we published, and I'll go through a couple of these. And again, these are all individual repos that you can fork and use in your application. And then we've actually got the storybook framework, which is what we use to build out these components. And so you can actually just run this locally and then start to customize and test various components that you either adapt from what we've built or even just add your own customized components to it. So if I run Storybook locally, here's essentially what it looks like. So using that same sort of breakdown that I talked about, you've got these atoms as your fundamental components. You've got molecules. So you got things like the way your account card is displayed, the way your address might be displayed here. Your block details. There's a gas card, for example, that talks about the base fee. So these are all pre-built components that you can again drag and drop into your application. And then these molecules and atoms get combined into building out more complex components, which we call organisms. So that could be things like your NFT renders here. So this is again, a little pudgy penguin collection. And then each of these have got their own little detail page. So this is an example of what that detail component could look like with a bit of sales history, floor price, and your attributes. And the nice thing about Storybook is this is all dynamic. So I can actually go here. It looks like the chain selector doesn't show up in the screen share, but down below where it says chain name, I can actually select the chain that I want. I can pick a collection and it'll automatically update accordingly. So I can see this data update in real time, which is quite helpful when you're trying to customize and create your own set of components. So that's a quick high-level snapshot of the Storybook framework, and pretty easy to get started and play around with this. Now, if we take a look at some of the templates that I talked about, so we've got for wallet and portfolios, for NFT collections. The one I just want to quickly highlight here is this transaction receipt. So if we go ahead and look at that particular repo, so this is taking any on-chain transaction and coming up with this stylized and customizable receipt that gives you sort of a way to extend this sort of transaction view from your application so that it looks and feels like your brand and not so much like a third-party block explorer. It's definitely a role, an important role that third-party explorers play. But if you think about the user experience when they go through an application and they make a transaction and then they get dropped into this this third-party application that's got so much data, it's a bit of a a disjointed experience, and that's one thing that we're trying to address with this particular type of component, the transaction receipt. And so there's a live template here, which we'll take a look at in just a second. And then you can actually do a one-click deploy using Vercel here. And this is all built, again, to just quickly test this component out. Very easy to get set up. So let's just take a look at this live deployment. So I can just, again, pick a chain. I can pick a transaction hash here. And so what this will do is it will use the API under the hood to fetch this data, and it will actually render some information about this transaction in a manner that's completely configurable and totally up to you. And so this is just looks like an element of a native transfer, and then an order on OpenSea that was fulfilled for an NFT transfer. Let me actually just go to the scroll scan, and I'm going to pick just a transaction from there. Looks like it's just a transfer. So let's try this. Go back here. We'll pick scroll mainnet, and I'm going to paste in a transaction here. And let's see what this renders at. Okay, so this is a multi-token transfer. I can see there's an element of a ETH transfer plus USD wrapped ETH. Again, this is just a very basic list view of the underlying tokens that were part of this exchange. But again, you've got the ability to completely customize how you want this flow of tokens from wallet A to wallet B with maybe some contracts, how you want that to appear. The data pipeline is set. Now the front end can be completely customized based on what you want this to look like. So very, very powerful. Just to give you an idea of how projects have leveraged this, here's an example of one that we built with a gaming project called DeFi Kingdoms. So again, if you were to use DeFi Kingdoms, currently you would go in, you would take a look at your portfolio, you would see some on-chain transactions that you've done, and it would drop you into some third-party block explorer. Now they've got this super stylized to their brand transaction receipt, and you can kind of focus in on the particular event details that don't overwhelm the user and kind of give you exactly a snapshot. In fact, you could probably take this and even mint this into your own NFT. So a couple of examples of just some nice stylized transaction receipts that have been built by a gaming company to give you a feel for how easy it is to customize, and then also what you might use this for. Cool. So that hopefully gives you a quick overview of the GoldRush kit. Again, it's all designed to get you up and running as quickly as possible. Let's just take a look at some of the other hackathon tools that we offer. So if you go to the DoraHack site and you're looking at the Covalent bounty details, I know we've got a link to this starter kit. And so let's just go through just the judging criteria. So this is how we would evaluate your projects. These are the various categories of APIs that we have available. So if you're building, for example, wallets, or if you're looking at the approval events that a wallet has granted a third-party spender or another wallet spender, you can actually see that list as well as the value at risk, and you can build in things like revoke functions to revoke that. There is a cross-chain activity, so you can see across all the chains that we support what chains a wallet is active on, there's transactions, NFT, DEX, and then if you just want to get the core fundamentals, primitive things like log events by topic hash or contract, you can do that as well. In terms of the tooling, we've got our unified API, so that's the REST API. We've got client SDKs in TypeScript, Go, Python. Recently also added an extension to VM. So if you're familiar with VM, there's a Covalent VM extension that basically incorporates and adds in our APIs under the hood, so you can use it pretty seamlessly through that framework that you already use. We talked about GoldRush Kit. and some of the templates, some shortcuts here, and then some examples of the types of projects that we've seen, as well as some project ideas if you're looking for some inspiration on what to build, and then a showcase of projects that have been built in hackathons in the past, and links to some of those details. Okay. I know there was a lot that we covered. One more thing I'll just highlight here. There's actually this. Let's see if I've got it here. I'll pull it up and I'll share this link. So we kind of did a bit of a deep dive on what developers who are actually awarded one of our grants, what they're building. And this might be useful. I'll share the link in here again. Okay, why if you can just share that link here, and I'll pull it up on my screen. So we kind of just did this quick analysis on what developers are building. So it's really interesting and probably not super surprising that AI kind of played a key role through a lot of the projects that are leveraging our grants. And again, Covalent being effectively a structured database, we're pretty primed for these types of projects to leverage that sort of consistent schema across all the chains that we support for LLMs or other types of AI-powered analysis. We've seen, focuses on some more interesting DeFi-related projects, improving Web3 user experience, and then with respect to AI, copy trading type of algos and projects. Automating some processes like accounting, and of course just analytics and forensics, looking at large clusters of on-chain data and relationships between various wallets and contracts. So worth having a quick skim through to see what other developers are building. And if you come out of this hackathon and you've built something super cool and you want to continue building, we do have this grants program that helps you continue with development with a lot of support from our end to use our on-chain data set. So I'll pause it here. I think we're almost a few minutes away from time, and if there are any questions, happy to take them.
Thank you, Harish. Let me bring in Jan as well in here. Thank you for sharing all this cool insight. Let me take us out of the... Okay. So thank you for sharing all this cool info. I shared the resources on the chat. Would be great for you to also share them on the Hacker Telegram group, or the Covalent channel has already been created. So it'd be great to have all these resources available there. For now, I think very clear how to optimize your hacks using Covalent. Very, very cool stuff. Jen, anything to add from your end?
Yeah, I think it was quite good and insightful to learn more about the GoldRush kit, which will help developers to build better and quicker. And it's also incredible and amazing that you have the opportunity for grants. So like if there's any, or the top projects, they could eventually qualify for some of the Covalent grants. So I think that's pretty good.
For sure.
Awesome. Well, thank you, Harish. We'll stay in touch. We'll be starting Vortex in exactly 2 days. So excited to see what people get hacking using Covalent. I appreciate you joining us, and I'll see you next time.
You bet. Thank you so much, Juan and Jen, for having me. And again, I'll be in the Telegram channel. Happy to help answer any questions or provide some feedback on what people are building. Good luck. Thank you.
Yeah.
Thanks a lot for your workshop. Thank you.
Cool, Jan. So we're getting towards the last workshop of the day. We have Evan from Sindri waiting for us in the backstage. We'll jump into a very, very quick 2-minute break as usual, and we'll be back.
Yeah, last but not least, but I'm excited for the last presentation for today.
Awesome. Alrighty, let's jump into the break. Alrighty. Well, hello, Evan and Katie. How you guys doing?
Doing great. How are you doing?
Very well, very well. We're at the end of today's session. It's been, let's see, 3.5 long hours, but excited to bring all this cool insight to hackers building on Vortex. So happy to have you guys here.
Happy to be here. Thank you.
Awesome. You guys want to tell us what you guys are up to in Sindri?
Yeah, I can take that one. So Sindri is, first off, zero knowledge proving infrastructure that's going to lighten the lift of anybody hoping to deploy a ZK decentralized app and doesn't really want to fire up all of the beefy servers to create proofs for themselves. So at our core, that's the problem we're solving. And what Evan and I are going to show today is that so in addition to lightening the infrastructure load, we also care a lot about developer tooling and lightening the, the time spent getting up to speed coding. So DevOps lift plus infrastructure lightening. That's what Sindri specializes in.
Nice, great. Yeah, definitely. Yeah, proving is definitely, like a big part of this whole, CK situation. Definitely brings in like a lot of infrastructure effort. So happy to hear that there's someone thinking about those devs that are willing to build using CK, but want to get, a more robust product out there, they need, additional infrastructure. So exciting to hear that. Jan.
Yeah, great to have you here, guys. And I'm also very excited to learn more about your project. We had 7 presentations and workshops today already. Yeah, very excited to have you and talk about zero knowledge.
Yeah, thanks for hanging in there. We'll try and keep it as interesting as possible going last.
And I feel like developers, they will watch it tomorrow or like the day after, so they're not as exhausted as us.
Yeah. This will be uploaded later, so all additional resources you guys want to share, I can include in the descriptions. We also have the Hacker Telegram group for you guys to share additional support to these hackers all over the world, which I don't know if you guys heard from the past 7 workshops that we've introed, but essentially we're having meetups all over the world touching these technologies through Vortex. So happy to have people from all over the world touching all of your guys' technologies. So very exciting to have that happen. Cool. Without further ado, I think we can take it off and kickstart it with, I think Evan is going to take the first half of the workshop. So are you guys ready?
Yeah.
All right, let's do it.
All right, thanks. So I'm Evan. I'm an engineer at Sindri. I'm going to start out by giving you a little bit of an introduction to some of our developer tooling and how that can facilitate getting started on a circuit project and deploying it, generating proofs. After I wrap that up, I'll hand it over to Katie, who's our cryptographer at Syndri, and she'll get a little bit more into the details about doing on-chain contract verification. So I'll hop over to the terminal here, and I'm going to start out by installing our command line tool, which I'm doing using npm. So this requires having Node installed on your computer. If you don't use a Node version manager, if you haven't really used Node much, you might run into some issues installing in a global location, permission issues. You can resolve those. We have some details in our quick start for the CLI, but you can also just run npx Sindri, and that's equivalent to running the Sindri command as if it was in path. But for brevity, I'll just run Sindri without npx for now. So the first thing I'm going to do here is authenticate the client. So I'll just log in, enter my username, my password. You can customize the name for the API key that's going to be stored in a local config file. You can select which organization you're associated with that you want the API key to be tied to. And then after that, we're good to go. That'll be used for all of the subsequent commands. So clearing that out, I'll show you this Syndri init command, which can be used to scaffold out a project using any one of the frameworks that we support. That comes with a number of helpful files that I'll get into in a minute. So I'll just start by calling our new circuit is equal. I'll use Noir. Okay. So coming in here, you can see that a number of files were put here. I'll circle back to these in a minute, but really quickly, I'd like to come over here and I'd like to create a repository on GitHub. And I want to do this first so that CI can start running, but then we'll circle back to what's actually in the project. So I'll create this repository. Come over to the settings, secrets for GitHub actions. Then I'm going to hop over to the Syndri website here, go into my team, API keys. I'm going to generate a new API key here. I'll call it the is equal CI key. Create that, copy this. We'll add this as a secret here and call it Syndri API key. And we're doing this so that when GitHub Actions workflows run, they'll have access to this API key to interact with our backend. So now that we've added that, I'll hop over here, copy this code for adding the remote in Git. So if we do this, okay, so we see our project here now. And again, in the interest of just getting the workflows running, I'm going to create a new tag here. And you'll see in a minute that we have out of the box with these scaffold projects, CI/CD workflows that you can, of course, customize however you want. But if you create a tagged release, this will automatically be deployed to production and associated with that tag. Okay. If I come over to actions, you can see 2 workflows running, one for that initial commit on main, one for this tag. We'll let those run in the background for now and flip back over here to show you something else. So taking a look here, you can see we have a source directory. If we take a look in there, this is a very simple Noir circuit. It takes 2 inputs, X and Y being the public input, and it just checks that the 2 are the same. So this just is designed to serve as a starting point for whatever circuit logic you want to use. Another important thing to take a look at is the Syndri.json file, which is just a manifest for the project. So you can give it a name here, you specify which framework you're using, the proving scheme, and of course the version of Noir. So this is used when you compile the circuit on our backend. So while that's compiling in the background there, let's take a quick look at doing local compilation. So one thing you can see right now, I don't have Nargo installed. One of the features of the Syndri CLI is we are working on adding a variety of ZK ecosystem tools to have transparent access to them using Docker in the background. And that's the SyndryX command. So you can see right now we support Nargo and Circumspect. So if I do SyndryX Nargo, that's going to give me access to Nargo as if it was installed locally. And it's going to use the exact version that's specified in that Syndri.json file. So I could do SyndryX Nargo compile. I can do prove. And when I run prove there, that creates the proof file under proofs. And then I can also do verify. And again, this is all done locally using Nargo. But now I'll flip back over here. So we can see on this initial commit on main, there are 2 jobs that run. The first is a lint compile prove. During the lint step, we do some static analysis, look for under constrained errors or other basic issues that can be found without compilation. We then compile the circuit. We create and verify a proof, and this is all done on the Sindri backend. So once that runs, we're pretty confident that the circuit at least compiles, and with the test case that we have, proves. So finally, we deploy that. The out-of-the-box CI/CD workflow that we have here will use a tag of latest, just as a convention similar to what you might see on Docker Hub. But then when you do a tagged release, similar thing will happen, except here, when it deploys, it'll use a tag that corresponds to whatever tag you set for that version. So flipping back to the terminal here, we can now generate a proof remotely. Show the help here. So we can specify the input file with which for Noir by convention, that's prover.toml. So if we specify that, you see we get a bunch of stuff back here from the API. The part that we really care about is this proof right here. So again, the expected location for Noir is going to be this is equal proof. I'm going to just remove that for now. And I'll show when you run Nargo verify that this is going to fail because it doesn't have that proof. But if we generate the proof again and use JQ to pull out that proof part that we care about, and just put that into and then run verify. We can see that we're able to verify locally that proof that we generated remotely. And in terms of these jobs here, I won't get into it right now, but you can set this up so that when you create a pull request, it's required to have this lint compile proof step pass before you're able to merge that into main. And you can feel free to take our starter CI workflow here and customize this however you see fit. And also just quickly mention that a lot of the stuff that I just showed here is covered in our documentation. We have very thorough documentation that we're very proud of. This is a getting started guide with the CLI. Here's a section that's focused specifically on this continuous integration. I'll share these links afterwards. And from there, I think I'll throw it over to Katie.
Thanks, Evan. Let me make sure I can share my screen before I start talking and get distracted. Okay, so at a high level, as a reminder, what Evan showed you is the Sindri CLI and how hard we've worked to make it like effortlessly easy to integrate with local circuit development. So he showed that the proofs coming back from Sindri verify via Nargo locally, and he showed how simple it is to set up these initial GitHub workflows in order to work as a collaborator on a circuit project and to iterate on Sindri while you do that. So now we're going to pivot and talk about sort of another, generally a heavy lift part of the stack that we're trying to make easier. So you have a compiled circuit and you envision some sort of on-chain application that consumes those proofs and unlocks some sort of behavior for proofs that verify. So what my part of the workshop is going to show is we're going to pick up where Evan left off. And because we're on the same team, I can pull all of the results that Evan compiled or deployed to Sindri so that I can work from them locally. And then we're going to use 3 of the Foundry CLI main toolkits in order to compile Solidity code, deploy it, and send a transaction. So I should say before I go much further, I'm just going to be using Anvil out of the box, which is like a generic testnet for Foundry. I'm not going to be using Scroll Sepolia at this point, but the environment change is pretty minimal if you get to the point where you want to follow along with this workshop and instead use the network that you actually intend to deploy with eventually. So first, let's these 2 boxes on the left here, that's what we're going to do first. I'm going to go to the front end and I'm going to retrieve a smart contract that was automatically created when Evan deployed a circuit. So let me go there. So this is the Sindri front end, and I'm going to pick the is equal circuit that Evan was just showing you. And if I go to artifact files, I can download the smart contract verifier for that circuit. So I have to open that up and you can't see it, but I've got Notepad open up to the side here in order to bring up the text of the smart contract verifier. And then I'm going to go over to VS Code to complete the rest of the steps here. First off, I need to initialize a Foundry project. So I'm going to say start up the project. I don't need to use Git because, again, I want to keep this simple, and these are just baby steps here. So I've got the Foundry boilerplate project comes with a smart contract like this, but we want something a little more specific to ZK. So what I'm doing is I just copy and pasted the Noir circuit proof verifier that I downloaded from the front end. So now I've got verifier.sol. That the next preparatory step that my outline mentioned was I want to get that circuit code that Evan was working with. So if I go back to the front end, I can grab the circuit ID. And because Evan and I are on the same team here, I can use the Sindri clone that circuit ID. And I'm going to say clone it into is equal, the directory I want it to be saved at. So now you can see that I've pulled all of the relevant files from Sindri. And so we'll be able to create a proof when we're ready to transact with the smart contract. So the next steps, in order to do anything else, I need to have a test net running. And so I'm going to start up Anvil. And so as you can see, Anvil prints out the RPC URL that you should specify. So I'm going to save that URL here so that everything I send later on will be sent there and not, some other network. But it also gave me a few wallets and private keys for wallets with money, and we'll need that to deploy our contract. So I'm just going to grab a random one. Okay, so we have the URL, we have a wallet with money, and the next step is to compile and deploy this smart contract verifier. Again, so we started with a Forge boilerplate project, which came with a script to deploy it that looks like this. We're loosely going to follow that template. Let's call it deploy.sol. We're going to create a Solidity script that will deploy our verifier. And in order to do that, we want to import the verifier from that source code that I copy and pasted in. And then we'll need, this doesn't matter too much, but we should just call this our deploy script. So we're going to start broadcast in order to pass in our public key. We're going to create a new contract of some sort, and then we'll just stop the broadcast of our public key. Okay, so now the question is, what do I fill in here in order to deploy this smart contract verifier? So this is going to change depending on what circuit framework you started with. So just keep in mind, you'll have to do a little bit of Solidity reading to figure out the right things to put in here. But I'll walk through how it goes for Noir. Noir has a library function handling the key, and this verifying key here was supplied when we compiled that circuit on Sindri. It's got a base class called base ultra verifier, but the actual contract part of it is just inherited from that base class. So ultra verifier is the contract that we'll be creating a new instance of. And with that, I think we're ready to deploy it. So in order to do that, we do forge script to let Foundry know we're going to be running a deploy script. We have to reference the specific one we want to run. Then we have to give it the RPC URL, which we saved earlier, and the private key, also saved earlier. The final thing is, if you don't enter this broadcast tag here, what's going to happen is it would simulate the deploy, but it actually wouldn't execute it on Anvil. So we need that last tag there. And it's pretty cool when you look at this Anvil terminal over here, you can see exactly what happened when we deployed. So the script ran successfully, and I think that means we are ready to move on to the next step, which is we have a contract address. We want to transact with it. We need to get a proof in order to do so first. So I think I didn't do broadcast correctly because it didn't give me a contract address. It's just one of those things where there's a lot of things to type. Oh, there's my typo. Okay, we have to redo this. This is what you should actually see. If you don't see a contract address, something went wrong. Okay, so we got to wait for the transaction to be mined. Okay, things are successful. Now we have our contract address. This is where we're going to be sending our transaction. So let me just save that. There we go. Okay, so now we need a proof in order to transact with this contract address. So we're going to come into the circuit directory that I downloaded earlier that Evan initiated. And if you recall, we have this CLI feature that will create a proof from the standard prover.toml input. So I'm going to ask Sindri to create a proof for me, and I'm going to save that proof inside a file that's called proof.json. So that proof came back, and it looks very similar to what Evan was showing you earlier, except the main problem is that this isn't native call data. So we have to do one more transformative thing in order to turn this into what the smart contract is expecting. So let me pivot back to the smart contract code here to say how we get the queue, how we know what we have to change. This is the main public function call for the smart contract that's going to verify the proof. If a proof is correct, it's going to output 1. If a proof is not correct, you'd have to read this code to gain more confidence about the following claim. But if it's not correct, it's going to raise some error codes. So in order to call just this function and not any other function, I'm going to save the function signature, which is verify, and it's going to be a bytes followed by bytes 32 array. So call data has to be formatted as raw bytes. The public inputs have to be a list of bytes. And that's what, that's just the issue here. We have to massage this data a little more. So what we're going to do is, I've already built just a simple shell script that turns the TOML public inputs into what it has to look like. So if I call that shell script, Noir, and I'm going to call that on the proof.json file, it outputs what the call data should be formulated as. So I'm going to just copy and paste that and dump that into a variable. And this is going to be painful because it's very long call data, and I forgot to put the quotes around it, so it was going to separate that line. Okay, this is actually going to work. All right, so we have everything we need to make a transaction with the smart contract we've deployed. Now it's just getting the arguments in the right order. So we're going to use the Foundry cast CLI. We're going to send a transaction to the contract address where we deployed earlier. We're going to call the verify function, and we saved that function signature inside the FCN variable. We're going to send the call data that I just pasted into the terminal. And then the last pieces are that we want to use the local Anvil network, and we're going to use our own wallet to initiate this transaction. So as you can see, Anvil received the request, and we just have to wait a little bit for the fun. There we go. So the status of the transaction was a success, and in order to get just a few more details about it, I can do cast run, which is going to show me the stack of everything that happened in this transaction as it went through the smart contract. So the return value is the Boolean about whether the proof was successful, and in this case it was. There was no error. And that, I think, I mean, we could jump in deeper here, but I don't want to muddy the main message, which is the following high-level script of what we did. So we created a proof from Sindri, massaged that data a little bit into call data, and then simulated how that smart contract verifier executes on a local test net. And we're able to rerun that transaction with visibility into what the smart contract was doing. So that's it for me. I think I don't need to share anymore, and I'll just say that I think while I was going along, somebody was sharing helpful links. So yeah, any questions, or feel free to take the floor, moderators.
Thank you,
first of all,
thank you, Katie. Thank you, Evan. Very insightful here. Getting very, very technical. I love it. Great. I mean, I don't have many questions here. I think there are some questions kickstarting in the Telegram group, so would be great to have you guys share some of these resources there as well. Yeah, I think we've made it to the end of the day, Jan.
Yeah, and thanks a lot for the presentation. It was very insightful, and you had a lot of great examples. So I feel like developers learned a lot from that workshop.
Awesome. Would mind asking from Sindri's perspective, what sort of hack do you guys expect to see or would like to see? What is like one of those use cases that you think, hey, we would love to see more of this happening all over the world?
Yeah, I think that in previous hackathons that we've co-sponsored alongside the Aztec team, what we've been really happy to see in the past is people making use of Noir circuits and the Sindri API to prove them, and then fusing some, like in-browser experience where that circuit is so big, you wouldn't have been able to just prove it in the browser. You sort of need to export that proof heavy lift to Sindri's API. So I think we like seeing fusion with any of the other sponsors, and obviously we want to see fusion with Scroll. But just we like creative applications, and we like zero-knowledge circuits that are big and require a heavy tool like Sindri's API in order to give you a hand.
Awesome. Well, let's see what comes out of this. Yeah, online hackathons, so all the globes participating. Let's see what interesting use cases come out of this. Cool. So without further ado, I thank you guys for joining us, and I'll be kicking you guys from the stage. Thank you, thank you, thank you. Bye-bye.
Thanks.
You guys, but thank you. Alrighty,
Jan,
I think we got it.
It's almost over. We made it through, let's see, 4 hours, 5 minutes so far. So definitely very, very interesting day today. A lot of workshops, a lot of different sponsors sharing with us what's building. Some of them got really, really technical. That's really motivating to see. And I'm pretty sure that, there's people out there who will definitely make the most out of this.
Yeah, and it was incredible workshops. I've learned a lot. I think that developers did the same. They also learned a lot about all those different technologies. I think we should also mention once again that developers should join the Telegram if they haven't done so. In there, they can get technical support also in terms of team building. If someone is still looking for a team member, feel free to share in there what you're looking for, what you're planning to build, what you bring on the table, and what your need.
Yep. Just pinged again the Hacker Telegram group. You can also find it on the Dora Hacks Hackathon website. So I guess the last call to action here from my end is for people to register before April 27th, 6:59 a.m. UTC. Let's share this link again. Awesome. And with that, I think we are done. I do believe we have additional workshops happening tomorrow. Each sponsor will be hosting from their own channels. And also we have the hackathon ceremony happening on the 24th to kickstart everything out. I'll probably be joining that as well alongside Raza and maybe other team members from Scroll and sponsors. Maybe you can accompany us as well, Jen.
Yeah, that sounds very good. So looking forward to the workshops tomorrow and the opening ceremony the day after. And to all the incredible projects building on top of Scroll and competing for the prizes.
Awesome. So with that in mind, let's close this up. See you, man.
All right. Thanks a lot. See you.